Okay, good morning, everyone. Welcome to this tech transfer event, Robotics 4.0, organized by the Shafir Industry 4.0 Network with the collaboration of Leitat Technological Center. I will be your host. I'm Maria Rosés, Innovation Manager at Shafir, a network whose mission is to promote and facilitate the transfer of Industry 4.0 technologies to society, especially SMEs. Today, we address a key technology in Industry 4.0, that is the field of robotics. Robotics is changing the way we live, the way we work. So without further delay, I would like you to help me to welcome to the stage Luis Romeral, Director of the Shafir Network, and Francesc Cortés from Leitat, who will tell us a little bit more about the event. So Luis, he's finally connecting online. So can we put his video?
Welcome to this session on robotics organized by Shafir and Leitat Technology Center with the assistance of D-Factory, a center to promote the innovation in industry and technologies 4.0 in Barcelona. So following, let me give you a brief overview of our Shafir, a project co-financed by the European Union in the framework of the ERDF funds. Here you can see my colleagues, Juan Manuel Hernández, Technological Promoter, Maria Rosés and Oscar Solaz, from Innovation Managers, Harilla El Haddadi, Administrative Manager, and our technician exploring technologies of 4.0, Joan Valls. Of course, they support the real operation of the network. And what we are Catalan technology centers and foundations, universities, and high-level research centers, which include most of the activity in research and transferring industry 4.0 technologies in Catalonia. This is a view of the research groups that are part of the Shafir network and technologies in which they are experts. And here you can see the specific technologies in which these groups stand out and in which they propose innovative solutions close to the market. Cybersecurity, advanced planning, IoT, robotics, etc. Our vision is to promote and facilitate the dissemination, valorization, and transfer of scientific knowledge in Industry 4.0 technologies to society and in particular to the industrial world, especially to SMEs. The role and mission is to promote the capabilities and research results of the groups for their valorization in the industry, to promote also the coordination of the network's valorization and transfer activities, and finally to advise and support the network members to boost their participation in international markets. We have two different kinds of activities to achieve these main objectives. One of them is related with the technological promotion, in which we develop a technological offering marketplace, identify synergies between groups and promote collaborative projects, participate in international congresses and fairs. A few days ago, we were in the Hannover Messe, for instance. We identify and promote the competitive public and private projects and promote also the participation of network members in international activities and projects. On the other hand, we also develop activities related to the innovation management, such as, for instance, identification and validation of the network's technologies capable of being transferred to the market. We design and implement training programs aimed at network members for valorization, transfer, and entrepreneurship and industry 4.0 capabilities, promote the transfer to the productive sector through patentability studies and patent protection, and improve the valorization process of the technologies to be transferred through improvements plans and increment of TRL and SRL labels. And finally, we advise and support the creation of TBCs, technology-based companies. This is this shows a view of our vision of the technology transfer processes from identification to commercialization, including maturing and pre-commercial support, and the activities that we carry out in this process are those of protection of acknowledgement and patents, increase of TRL, SRL labels, and support for the creation of the new companies, TBC, as I commented before. We organize support for groups and researchers through calls for the financing of these activities, that is promotion of patentability, increase in TRL, and support to the creation of technology-based companies with different tools in each activity block. Regarding the training, we promote also the training of researchers and entrepreneurs with the following training blocks: valorization and protection, business management, entrepreneurship, and entrepreneurship support programs. Of course, we organize this training according to the technologies and sectors in which the Shafir Network researchers are most interested. And finally, we organize and support from Shafir all the technical, financial, and economic interface with the administration. So it was a very brief view of our activities, and you can contact us and follow us on social media and nothing else. Finally, enjoy this workshop on robotics. Thank you very much for your attention.
Okay, thank you, Luis, for your presentation. And then now, please welcome to the stage Francesc Cortés. He's principal researcher at the Robotics and Automation Unit at Leitat, and he will do his presentation. Okay, here's your microphone. Thank you.
Okay, yeah, it works. I guess next means next, and back means back. Okay, nice to meet you. Welcome to the Factory facilities and initiative. I'm area manager from Leitat. Leitat is one of the actors in the factory. The factory has mainly three actors: technology producers, technology consumers, and Leitat as innovation agent to create new projects, new things, and stimulate the creation of new value in the factory. This is a presentation about Leitat and about what Leitat does in the factory. In fact, Leitat is a very old company, established in 1906. It was not a technology center at that time, it was another thing, but it's the same company. We are located in Terrassa. We have other places, including the factory here. And we have also one branch in Chile, in Santiago de Chile. Today we are about 500 people in Leitat, plus associated companies. Leitat is very active in European projects and in national projects. Now we are running about 100, we are participating, some of them leading or not, 100 European projects and 200 national projects, okay, today. And the revenues of Leitat is about 40 million euros. Okay, sorry. Leitat has four main areas: the engineering area, that is where robotics belongs. But we have also health and biomedicine, circular economy, and applied chemistry and materials. That is, applied chemistry and materials is the origin of Leitat, really is the original activity of Leitat. Okay, Leitat is a technological center, so what we do is help companies to be more competitive, and we work in an open innovation model. It means that we are very flexible in the cooperation models, and we can do any cooperation with at private level or at financial level at European projects or national projects. What we do in the factory? In the factory, what we do is the technological management of many labs, and we are the innovation agent of this initiative. Okay, so what we want to do is to add technological value to the factory initiative. Then we will run now later, when the people that is here, we can visit all this stuff physically, so we can later see what the labs in real. I'm sorry about the people that is in streaming, you cannot do that. But anyway, you can see what we have here in this presentation. So the first one is the robotics lab. That is the lab that I'm running. Basically, robots are tools for us, are not, our goal is not to create new robots. Sometimes we do, but our goal is to create new processes, new functionalities, and new abilities that the robots needs to have to get or to perform some activities. So We are focusing on force control, on vision, on sensors, on artificial intelligence to give robots new functionalities. Okay? We manage the space, and of course we have many levels of, depending on the complexity, we can cooperate in many levels with the companies. The Additive Manufacturing Lab, before it was in Terrassa, is an aggregation of manufacturers that are here to promote the introduction of 3D printing or additive manufacturing in the industry. So what they do is they have here machines and they test new materials and new designs in order to show to the industry what are the advantages of this technology by running, of course, innovation projects. A connectivity lab is not right here, right now, is still in Terrassa, but the connectivity lab basically will be IoT and communications and data analysis. So this lab will be placed in level 1 and is still in running, or it's still to be installed. Photonics and Vision Lab. The Photonics and Vision Lab, this is already here. Basically, what we do is photonics circuits or photonics setups, and the most of the time, what we do is the reaction of materials against photonics. So we use photonics as basically sensors today. The future is that we want to use photonics also as communication, for communication and for other processes that photonics is involved. But basically, now we are very expert in measuring and identifying chemicals using photonics. The last one is, let's say, a small data center devoted to artificial intelligence. This is really not a monolithic data center. It's a data center that we can install here the technologies that the companies want to test. So we have here technologies from Huawei, from NVIDIA, that are installed in this data center and are used in order to test IA algorithms or neural networks or data processing, etc. And that's all. I mean, Leitat is here with personal lab. We can do collaborative projects. We can do service contracts. And our goal is to make companies competitive using the Industry 4.0 technologies. Thank you.
Okay, thank you very much, Francesc. Thank you for your presentation. Now, to continue, we will start by reviewing the main trends of robotics in Europe. And all the way from Denmark, we have here Kurt Nielsen. He is director of the Danish Technological Institute, and he will present Denmark as a success story of tech transfer within robotics. So welcome to the stage, Kurt. Thank you for coming. So here's, thank you.
So, yes, is it on? I'm just wait for the slides to appear.
If you can. Yeah.
There it is. Okay, yeah, but thank you very much for your kind invitation. Very excited to be here and really impressed already what I saw about the D factory, looking really good. So I got this exciting headline to talk about the success of Denmark in this. Let me present what I have and then let you be the judge on how good we are doing. I think we should already have the goal to be even better on doing technology transfer. It's really important to do it and it's really hard to do it. So I think, of course, we always need to share best practice on how to do that. So I brought a number of examples on that. And actually, I split it into two, because I think technology transfer is really take two parties. It takes the end users and it takes the technology providers. And sometimes the drivers can be the end users, and sometimes it can be the technology by itself. So I tried to bring some example on both. So just briefly about DTI. We are a research technology organization located in Denmark, a bit around 1,000 employees and working in technology in general. When looking into robotics, we are having around 3,000 square meters of robotics labs in the city of Odense. You can see some of the labs on the right here. And really what we work on is the combination about, of course, improving and foster innovation in the robotics industry on one hand, but of course also make sure that we have, that the end users are becoming really good at using these new technologies. So that's really what we try to help on. And we have been doing a lot within manufacturing throughout the years. Our institute is from 1906 as well, actually. Robotics, we just have 20 years anniversary this year. So been working on robotics for quite some years. Manufacturing being still the biggest domain. But as you can see here, we're working now in robotics in all kinds of domains. And we really see a lot of growth also outside the manufacturing industry. So if we look a bit into what's going on in Denmark, and a bit back to the heading, so we are definitely a growing industry. The robotics has become an industry by itself. So now Denmark is not only using robotics, but we're also developing new robotics industries and new robotics companies. And we're doing quite a lot of export. As you can see, around 60 to 7% of all the robotics going on in Denmark is actually exported outside. A bit more than 300 companies spread around Denmark. A lot of these is also newcomers, new startups, scale-up companies coming for the last 5, 6, 10 years. So, going to the end user side, some of the things we really see is that there's a lot of outside pressure on the manufacturing companies which need or call for more robotics. So this is just one case from the windmill industry. We all know that we need to do more and more on these green transition. That also means that we need to produce more of these windmills. So there's a need for doing more, but the capacity need to grow likely. So now this is actually a couple of years old. So for 2 years ago, they said that need to have 3 times as many windmills in 2030. I think that number probably already grow for the last 6 months or so. And the question is then, how can we use robotics to do anything about this? And what we quite often see is really that for some years ago, it was really what we would call hand-on. You went through your factory and found out where could the robotics be used. But now it's become more a strategic question. How can you use robotics to fulfill the goals that you have, like doubling your capacity in less than 10 years? So the question is, of course, how do you make this combination? How do you go from an ambition and the need for doing more robotics? How do you find out what are the right robots that you need to do? So this is really often what we see is the task in hand, that we need to make a plan for that, not only for what we want to do for the next 6 months, but maybe what we want to do for the next 5 years. So this is a bit similar to a slide we just saw earlier on. So this is really making sure we have a process for this. How do you go from the early ideas and having the early thoughts on how you want to have this technology in, but also to make sure that you have a plan for getting it implemented in the end. Because if it somehow ends in the labs, it will not really make the impact that we're looking for. And now the talk is about technology transfer, and I put the arrow on the latest part on this, but actually it should probably have been from the start on. But what I mean with this is, it will start out by a need by an end user, but at some point, of course, being an RTO that DTI is, we also need to make sure that the robotics industry is involved quite early in the phases, so that we have this handover of technology that we do in the labs, and it's also turned over to the companies who will make the final installation. So this is of course important that you somehow think these steps through from the starting point, that you don't just look at how to do it, but also how do we make sure that it can be implemented afterwards. So just to give you one example on this, this is a German company called Weidmüller. I think they're around 5,000 employees or so, quite big, and they're doing these electronic housings. And actually that's one of the customers that we had lately. They just was announced on the Hanover Fair last week. So they came and they wanted to in some cases replace the human worker on this and have a robot help on some of this assembly of the electronic housings. And this is really a good example on what's going on. I think that more companies want to have robotics as part of the solutions. So we had this kind of collaboration with them, and this is from the fair last week. And the step one is to be able to put these and install these using some forced torque on that. So that one part of the process. The second part is also to be able to put the wire into it afterwards. And again, just a film from the fair. And it's not really that I want to dig that much into the case by itself, but it's really, again, to show that it's important that when we do this, that we have a process for getting into to the final destination on this. And the first picture you see here is actually from the lab. So I think that's what we normally do quite often, is that we have end users coming in, we find a good example, we do a proof of concept, proof of technology, show that it's feasible, and we do it in a stage gate model. So if we can somehow break the difficult part on the process, we go to the next stage and the next stage, such that we don't have a complete investment from the starting point, but we continue investing if we can actually make it all the way. And then through that process, you have some validation and making sure that you can progress, and then you'll have a final solution in the end. So, a bit on the robotics side. For that, I brought some examples from Denmark. Universal Robots is original from Denmark and still have all the activities in Denmark. Started in 2005, and I think in 2005, not many people were looking to Denmark for robotics. But Universal Robots was one of the companies indeed changing this a bit. They are quite big now. They're close to 1,000 employees. In 2015, they were sold to Teradyne, a US company, for around 300 million euros, so quite a substantial amount as well. They're still leading in the collaborative area. And they really had a lot of impact on the community as well, because we see a lot of other companies now using this platform as technology or sales channels as well, and using it as a channel to get into the market. If you're doing a gripper, if you're doing a camera, if you're doing welding, if you're doing gluing, whatever you're doing, and you're doing this add-on tools for the arms, then you can go in the footprints of UR across the world on that. The story about UR is really that it started as one of these end-user problems. We had a food company who wanted to put the pepperoni on pizzas. And I think there's still a problem that we see in a lot of projects, so still going on. How can we handle these soft and not rigid objects with robots? And we tried to use traditional industrial robots for that. Then some student at the local university, University of Southern Denmark, they tried to solve that, and they found that it was too complicated with existing technologies, so they invented the universal robot arm. So again, taking the real problem into consideration and trying to solve it, and then getting new technology in place through that. Mir, quite a big company as well in Denmark, doing mobile service robotics for internal logistics, primarily for manufacturing, but also outside manufacturing. And it's a bit the same story, that now we have a platform that we see a lot of Danish companies making the application on top of this, and also doing export on that as well. Another case, Odeco is doing, they're cutting this EPS cutting for doing concrete forms. So this is one of the reference cases, a building in Dubai, where you can see you have these very organic shapes. So you use the EPS to cut that in organic shapes, and then you can have these as a form for the concrete afterwards. The first company in Denmark going to the stock exchange in 2019, I believe. Yeah, so I think really, as I mentioned, back in 2005, a lot happened, but really it was in 2015 when Universal Robots were sold. I think that a lot of people got their eye into that there's going something on in robotics in Denmark. So late 2015, we established this incubator, the Odense Robotics Startup Hub, and since we have had 35 companies through the hub. Some of them is within manufacturing, some of them is outside manufacturing, some of them is drone companies as well. It's been quite successful, as you can see. After they leave the hub, 80% of them is still alive. And I think this is a really great way to do technology transfer as well, to really make sure that the technology come into new companies. Yeah, so this is one case. So we have Lasse here. He was the first employee in Universal Robots. And when he left Universal Robots, he started his own company called Purple Robotics. So they made the gripper out here, a vacuum gripper. And really they knew everything about electronics, they knew everything to do the gripper side. We helped them from our side on making the integration to the UR robot. They were in the hub for 1 year, and when they left, you can see now it got a new label, now it's an on-robot gripper, so it was sold to on-robot. The amount is not disclosed, but I think it was a nice sale probably. So this is also a way to get it into market, right? Already after 1 year, the purple robotic ribber was for sale in 35 companies, so it was going really, really fast. And I think that's really the main in this case, that we are becoming really good on doing speed. So the speed to market is of course really important on these new technologies, also for these kind of products, which is add-on tools. Another case is this farm droid. They're doing they're removing weed from the field, and also doing the putting the seed into the ground. So it's driving autonomously around on the field, driving very slow, which means that the legislation will not be an issue. So it's actually safe to have it operating, which is normally can be hard to solve that. We help on the accuracy. Of course, when you're moving around in these fields, it can be hard to be very precise. They're using a very precise GPS, but there's also something very locally on the robot, so we're helping on that. So again, we're going in with niche but specialist knowledge to help them on one specific problem, because a lot of the other things they can handle themselves.
Ideen til Farm Droid.
I'll just skip that one. So how to do tech transfer, to try to sum it up a bit. So I think what we've been really good at is we need to make it really easy. We need to be very fast and having all the contractual part. We need to get aside with the IP discussion. We need to make sure how we get all this in place in a fast way. About scope, I think it's really important that we not only talk about what to do, but also how to do it, and also how to do the transfer. I think quite often earlier we saw that we had some exciting results in the technology we were doing, but then who should take it for the next step? There's normally, when we do technology transfer, there's a lot of investment left when we get to the last part. We have a TL7 product maybe in the lab. It looks very promising and very exciting, but who is going to put the money in it for TL7 to 9? Is it the end user? Is it a robotics company? Is it a combination? So really being good at addressing that is really important, I think, to show how you do that. And of course also the IP question on that. Sometimes we see that the end users, they actually want to become a robotics company and have the robot as part of the product. But sometimes they also just want to have a solution and want a robotics company to take it for the next step. So have that in place. And sometimes this is something you maybe acknowledge and find out through the process, but you need to have that in focus as well. And then trust. I think what we has been really good at in Denmark, but also in the city in Odense, where I'm from, is really that we are very locally. And I think that's one of the good things about being maybe a small country, that everyone is very close. It's still not a very big industry, so a lot of the people there still know each other. That also means that we can gain and build a lot of trust. Because no matter how good you do the contractual side, no matter how well you define this, there will be a lot of uncertainties on this journey. So trust among people, I think, is really important on that you have trust in that you can actually solve this. So that's something that we do quite a lot. That's of course also a reason that an event like this today is really important, because you need to meet people, you need to talk to people, you need to build on that trust to make this kind of development, because it can be hard really to define how you will solve it. But if you trust people, you will find a solution in the end. And then the last thing I put is really that what we do from our side, at least, is we really try to focus on the specialist knowledge. We have a lot of specialists which we can put together with the specialist, because that's really also where you need to have, of course, the exact collaboration. When we're doing something about, for example, on the farm droid case, where we need something about accuracy, we need to have our specialists working very close together with their specialists to make a solution in the end. And again, they don't really need to care a lot about the contractual side. They just need to focus on solving the problem. And again, then we're back to the trust. So I think just to sum up, some of the things we've been doing really good is that we're going from just using robots, you could say, but also to having a robotics industry, but also that we really build a network, and we also put a lot of investment into building the network and building the company side. So we do a lot about investing into getting new startups out. We do a lot about meeting each other. We do a lot about these informal talks as well. So it's not just about doing exact work, but also really to build in people and build in trust. So that was my final remark. So thank you very much for your attention.
Thank you very much. Okay. Thank you very much, Kurt, for your presentation. Excellent presentation. If you have any questions, don't worry, we'll have time for questions after this first block. And then now to move on from Spain, we have Alex Salvador. He's Managing Director at the Asociación Española de Robótica. Welcome to the stage. So,
thank you.
Yes, next.
Okay, here we
the
are.
floor is yours.
First of all, thank you. Kurt, it's been my pleasure to learn from you during this presentation. Thank you, Leitat. Thank you, The Factory. This is an amazing venue, so we hopefully will be doing many, many things with you in the next coming future. I will be presenting in less, hopefully 10 minutes, main facts and figures regarding robotics industrial and service, main trends. The point for us, explaining a little bit about us, AIR Automation is the Spanish Robotics and Automation Association. We've been there running for 37 years. Since 1987, we are founding members of the International Federation of Robotics, and this is a key important issue for us because we are delivering the official figures on behalf of the IFR in Spain. So we will be trying to set up the frame maybe for later discussion with these facts and figures. And since April 1st this year, we've been the first robotics and automation representatives within the COE, which is the biggest Spanish confederation of enterprises. So this means a huge honor and a huge challenge to defend the interest of robotics and automation within the COE. Let me show you a picture. We are covering the whole value chain from the manufacturers till the end user. Basically, the channel of engineers and integrators, of course, technological centers like LICTAT and EURECAT, both members, associates of AIR, and also polytechnical universities, Formación Profesional Dual also, and we are going and setting up We Are Education initiative to put the robotics into the primary and secondary school from 6 to 12 years old also. So many, many projects in parallel running. This is the picture, bottom left, first seated is Luis Basáñez, our current General Secretary of AIR Automation. So he is really running, he's been running for 37 years with us, and he's been recently re-elected as the Secretary for 4 years more. So we were founding members of IFR. This is current board of directors, president coming from Matching Vision, Salvador Giró in Faimon, Stemmer Group, and the first vice president woman in the whole history of the association, Pepa Sedó, EURECAT. You look the level of the vocals from Technalia, Technological Center, Festo Automation, ABB, and KUKA Industrial Robotics, UR, PIL Security, and Inali and IDASA that are engineers. So the mission at the end, Kurt, is building trust. Thank you for that one, because we are trying to build trust. We've been growing from 40 associates 2 years ago to almost 100 this year. We are now 98 associates. So we are trying in this third year of the new age of the association to build to consolidate this growth, first of all, and to build strategic alliances with many other key players of the industry to become the leading association in Spain. I like the last one, humility with vision. This is our key pattern, and we are trying to follow this path. We are small, but we want, and we have the vision to growth. So when it comes to the industrial robotics statistics coming always from IFR, maybe you all here are well aware of these figures, but the people who is watching in the streaming, maybe they are new for them. In 2020, the market growth was roughly 1%. So this meant that this was the evolution. We reached almost 400,000 installation of industrial robotics overall, all over the world. You know that in 2018, we reached the peak of more than 400,000 robots installed. And when it comes to the customer industries developed, in 2020, for the first time in history, automotive was not the first industry using robotics, but electrical and electronics. And this is following the growth, impressive growth of China, as we will be seeing soon. Automotive, the second one, and metal and machinery is the third one. We'll see that the Spanish picture is a little bit different. This was China in 2020. Bear in mind that China has recently set up a plan to install in less than 3 years almost 250,000 robots overall. This should be in 3 years probably 50% of the market share. But take into account also that Japan is still the first producer of robots. It's the first mill, and they are installing many of them in China. The States in third place, Korea and Germany, when it comes to Europe, first one in Europe, Germany, Italy, France, and Spain reaching 10th position. This means almost 3,400 robots. The robot density is a key figure for us because it's measuring the number of robots per 10,000 workers in the industry. You can see the average. I don't know if the laser is properly working now in the screen. The average is 126, the red line. We can see that Denmark is in 10th position, Kurt, and Spain is the 15th position. So we could deduct from this picture that we are over the average and we are doing quite well. But this is going quite well depending on the industry. The 203 robots per 10,000 workers in the industry is an average. And it's an average among two positions that we'll be seeing soon. When it comes to density in the automotive, the blue line, Korea is leading with almost 3,000 robots per 10,000 workers. Japan is in the 8th position, and in the next slide we can see that Spain is leading installation of robots into the automotive industry. So this is quite good news. Not quite good news is the average of the rest of the industry. So the challenge for the country is to pull up this average from the general industry, which is only 107, and pulling up to the level of efficiency and effectiveness of the automotive industry. So we have a lot to do, a lot of job to do, and the Spanish Association is working hard on that. Quickly, this is a nice discussion card. The percentage of collaborative among the whole industrial robotics installation is fixed between 5 and 6%. But in Spain, we can guess that is above 10%, this percentage of collaborative robots into the total industrial figure. But it's growing 2 digits. We'll be seeing that industrial overall is growing only 6%, but collaborative robots is growing 2 digits. So this is quite good news. Spain was reaching the peak of 5,000 robots and 300 in 2018 also. It's been declining because of the automotive crisis and also because of the pandemic. We've got the new figures of 2021 from the last week, because we are covering our own survey within our associates, and we are delivering these figures to the IFR. And imports grew by 6% last year in Spain. So we are following this average. This is 2020, but in 2021 we grew by 6%. When it comes to industries, if we sum up automotive and motor vehicles, in Spain, automotive is still the first place using robots. Food and beverage, second one, and metal and machinery, third one. But when it comes to our own figures that we are covering, that we are gathering, in 2020, for the first time, automotive only install 4 out of 10 robots in Spain, 39%. And which other industries came to help the automotive industry? Metal, 19, and food and beverage, 18. The picture of 2021 is automotion even declining more, down to 32%, and metal growing up to 30%. So we've been seeing the metal consolidating as the second industry when it comes to installation of robots. Really fast, short-term market determinants, global economic recovery, scarcity of raw materials, you all know well, advances in adjacent technologies, human-robot collaboration, above all, and sustainability. This is key issue for us, for the association. And in the last one, lower total cost of ownership, we can see the RAS and robot as a service and all these trends, okay? And of course, localization of supply chains. And when it comes to service robotics, faster than the other one because the figures are not covering roughly, Francesco, 20% of the market, so are not that much reliable as the industrial one. But we are following and we are informing as well this year to the IFR of our associates regarding service, which is including also mobile robotics. Bear in mind that service is including mobile robotics. So you can see that this 130,000 units is really a low mark, should be double or three times this quantity over. But this is more important because IFR is fixing very well the trends and the applications for mobile and service robotics, first of all AMR and delivery, last mile deliveries, cleaning and disinfection, medical, social robots, and also automate restaurant. You were talking before this card. Well, this is more or less the same. I like this slide because it's showing that Europe is leading not only in terms of suppliers of service robotics, and Spain is leading in mobile robotics, probably second behind China, but also in number of startups. So these are really good figures for Europe and for Spain. And safety, security, and privacy, and democratization of robotics. This should be my last point. There are some slides more, but I will like to stop here, maybe some questions regarding these figures, and leave the floor to more specialist people showing you probably a more funny picture of the market. Thank you very much.
Okay, thank you very much, Alex. Thank you for your presentation. So next up to the stage, we will have Francesco Ferro. He is CEO at PAL Robotics, and he will be introducing his company. Thank you. Francesco, your clicker. Okay, so the floor is yours.
I will finish the presentation of Alex.
Yeah.
This is very good. We are also there in the association, so it's good. So, and then, okay. So, it's a normal presentation. It's our corporative presentation. I will try to don't annoy you with all the things that we did or whatever, but I will try to, inside the slides, also comment something that could be interesting for you. So, about the company. We are based here in Barcelona. We have a lot of nationality. At the moment, we are around 80 employees, and we are specialized on service robotics.
Deep in the heart.
I will skip it. You don't need it. But about the expertise, we are covering all the value chain from the production up to the services and post-sales things. And this probably is the most important slides, is the vertical that we created. So when someone was asking me some years ago, what is doing PAL Robotics? The question was very difficult because it was service robotics, yes, but what it means. And so some years ago, we just defined these 4 different verticals. So from one side, there's the social robotics. Then we have a legged system, so we call it humanoid, but it's based on the biped humanoid robots. That is something that we did from scratch. Then the mobile manipulator, like the Tiago families. And finally, the intralogistic. But we will see more about it in the other slides. And this is the picture about all the robots that we did since 2004. The first 4 that you can see here are a little bit gray because are just prototype that we, and now there are in London, in the Science Museum of London in a permanent collection. So we did the history of the probably Europe legged system. And we make part of different associations like Robotics, IR, Esparob, and also we made part of the PPP of 5G. About the different robots, this is just the first one. So I will not bore you with the different videos, but here you have the highlights of what were these robots. I skip it, so you can check on YouTube, and probably also the presentation will be available, so don't worry. One important slide is also about the collaborative project, because we really believe that we have to collaborate more in order to have more and more robots in the real life. And so at the moment, these are the project that we are doing, ongoing. In upcoming, we have several ones that are starting now. And the past project, you can see there are several things. And so in the vertical part, we just defined the healthcare, different from agri-food, that we are now a big project with UPC, also the canopies, and the industry side, and also the R&D that is in our ADN. These are just picture of logo of company where we worked in the project. Just to have another number, more or less in the turnover is around 18% of our revenue. About the social robotics, there are platforms in order to make social interaction. So we added the RIM robot that you have seen in the previous slides, and now we just coming out with the ARI robot. That is acronyms for Artificial Robot Intelligence, but it's also a name here in Catalonia, so it's a good name. And the idea is to improve all the human-robot interaction. So at the moment, the robot is just, let me say, evolving. We already have a second version, and at the moment, the team is leading from a professor ex-professor from Bristol Laboratory, Séverin Lemagnan. And we are also supporting the ROS for HRI in ROS. This is just marketing video, so I think that we can skip it. About the legged system, so the humanoid robots, we have to, is like I said, something that we did from our history, from the beginning, and so the idea is to push this. So why humanoids? Because probably now we have seen that we are also doing wheeled robot. But humanoids is just in order to push ourselves to use the same tools that the human are using. So also stairs, for example, we can't pretend or think that we will change all our houses without stairs in the future. So we have to still work on it and develop it, because at the moment it's just on the research stage. This is our point of view. But based on that, with this different platform, the RIM-C is still a robot that we are selling in our catalog, and we also implement a lot of good things about it, and like the whole body control, the fact that the robot could move different stuff. And another important issue is that we are based 100% on ROS. And I think that there are also a lot of sound. I don't know if you can take it out the sound, because I don't need the sound for the video, because yeah, probably will. Yes, the difference between the RIM-C and the Talos is not only the height of the robot, but it's also a different. Thank you. It's also the completely different technology that we are using in these robots. So the RIM-C was based on the CAN, also electrical motors, and in the Talos we just implemented the torque control thanks to the sensor, torque sensor in each joint of the robot. Thanks to that, the torque control that we are doing at the joint level, it allows us to have a more dynamic also walking, but also a very, very reactive robot with electrical technology. So this is the things. At the moment, just nowadays, it's very common to find this in industrial robots, just our arm that are fixed usually on a table, and doing a complete system like a humanoid biped robot that can move and that have to have the equilibrium at any moment is something really complicated. especially for control point of view. And yeah, the platform was built with the requirement with the LAS, the university in Toulouse, in France. And one of the important things is the weight. So it can take up to 6 kilograms with the stretched arms. So this is something complicated. For this reason, robot is also very heavy, in our opinion. And for this reason, we are also thinking to change. And in next slide, I will show you. And but before that, based on the torque control, we use the solo. We are now helping the community in order to purchase this robot. So it's not our invention, but it's open source from software and the hardware point of view, but we are just commercializing it in order to help the community to don't purchase components by components, because it could be a nightmare, and we are doing this, and it's a nightmare. So it's done by Max Planck and New York University, and for sure the LAS. And now it's also Wi-Fi, but yeah, this is our development. And so for this reason, I said that we are changing our mind, and we are doing robot even more dynamics, like the Kangaroo. The Kangaroo is a project where the robot has to be able to jump. And in the picture that you can see there, with some tests, this was last year. We presented at ICRA, and the idea is to have a more agile robot in torque control. And the dynamic, the configuration of the legs is based by bar, and so all the motors and the electronics is up to here. And so this allows us to have, we hope, a better robot. And at the moment we have all in simulation, also the dynamic model. And if you're interested, just contact us. And here there are also other demo that we did with the robot. At the moment we are just focusing on the low part of the robot, and here you can see the first test that we did. We also presented in the ICRA in 2 weeks ago in Philadelphia the test bed that you have seen in the previous video, in order to also show the different capability of these robots. But now just move the mobile manipulation and the Tiago robots. I know here that some of you already have touched this robot or are working actively on these robots. And the idea is to have a robot that could, with different arms. You could have 1 arm, 2 arms. Now you could have even not a differential wheel, omni-wheel platform with the robot. And so the modularity has not to be only on software side, but we try also to have on hardware side with this solution. And for this reason, you can change different and effector. Also the mobile base, you could have different mobile base. You can have a different head. You can also add a different sensor. And the facility, the usability of this robot has to be the most important part, in order to focus on these 4 different pillars that are not only manipulation, but also the perception, that is very important to manipulate some objects, the navigation, and also the human-robot interaction, that we are using the same software that we are using with the ARI robot. And now, Dulcis in Fundo, like said the Latins guys, is intralogistics. And we started this with a lot of pilots, especially with the Tiago base. And at the moment, we have different Tiago base. You can see over there the Omni base, that is with Omni wheel. And we are doing quite well, in the sense that we are doing a lot of, not sales at the moment, but pilots, a lot of pilots. And this is very helpful. And with the last new generation Tiago base, we are also approaching the food industry with a different behavior, like, for example, humidity, also water. So there are environments that are quite harsh in order to have a simple mobile base. And yes, the idea of the Tiago base is just to move the things around, and also the footprint of the base is the most important part. So we don't need to see this video, but these are, for example, some video with a real example that we did. And One of them, for example, this one, I think that it was in the Nissan that, yes, just near here, and also now a European project. And finally, this one, it was during the pandemic, where we just collaborate with the Evila project in order to have a disinfection robot that can disinfect the different environments. Even here, for example, could be useful. And the most important at the moment from revenue for PAL is the Stockbot in the retail market. And here we have one of a big brand that probably you know, where we are now selling a lot of robots. We are speaking about, we are reaching now the 200 units. We are in 12 countries, and we are doing installation and support and maintenance of all the robots. So they are doing inventory every day, and in some shops, 24 hours. So it's something very hard, and but the robot is working quite well. And now we are doing also probably in few months we will also have other big retailers where we are working even bigger than Decathlon, that we are working from long time, that probably we will disclose what we are doing with them. And the idea of the Stockbot is just to make the inventory, and so going through the shop during working hour and detect all the RFID tags, because it's based, this solution is based on RFID, and also detect the misplacement of every item in order to help to don't have the out of the stock, and so have a better management. And that's it. I think that I take the more than 10 minutes, probably 11. But the idea, the message that I would like to share with you is that we are constantly looking for new partners in order to make new robots, and to just try to give some solution, like I've listened in the previous presentation, to real problem that we are seeing. Because we are speaking about robots here in this room, we are presenting beautiful picture or video like I did, but I didn't see any robots here. I didn't see any robots that is helping us now, also during the presentation. And this is, in my opinion, something that we are working in order to make this possible. So thank you very much.
Thank you, Francesco. Thank you very much. Thank you for adjusting to the time, because such a great presentation. You do so many things at PAL Robotics. So now let me welcome to the stage Andreu Corominas. He is CEO and co-founder at Beta Robots, and he will talk about mobile robots in the Industry 4.0. Okay. Thank you. Here's your clicker.
Okay. Thank you. Good morning, and thank you to the organization to invite us and to have this the opportunity to talk a little bit with as an expert people. So I'm Andreu Corominas from Beta Robots, and as a CEO and co-founder. Beta Robot is a company founded 6 years ago. It's a local company, and I'm not here to talk a lot about my company. I want to take benefit of the occasion to share some insights, not figures. Alex shared figures very well before. So I will share mainly insights about the mobile robotics in the Industry 4.0, but especially the trends, okay? So I identified three main aspects that are pulling the sector. So I decided to represent them as a triangle, and in each vertex you see one of these aspects that is pulling, and it's expanding the area. Okay, so in fact these three aspects are answering one question each one. The first one is to whom we are selling robots, and the second one is how do we sell robots, and the third one is what do we sell. Okay, so and I will briefly discuss each of these vertices with another triangle. Okay, so the first one is to whom we sell robots, markets. Okay, and I identified three main trends here. So intralogistics, okay, warehouse, retail, hospitals, cleaning, and so on. Then outdoor, there are a lot of outdoor applications that are knocking the door, okay? And the third one is inspection. For instance, wind turbines that Kurt shown before, okay? The second triangle is how do we sell these robots? And we can sell them as in a classical way, but a trend is to sell them as a service or renting the robots. So industrial companies don't want the ownership of a robot. They want to solve something, okay? Then another trend is to sell the software as a component, not as a it's like a motor or a wheel. So the manufacturer of the robot also buys the software, okay, as a component, okay. And a third trend is to sell big solutions. That is the role of integrators, where robots are just a part of the solution, okay. And here I want to stress that this vertical and horizontal in intralogistics, for instance, is solving the horizontal movement and solving the vertical movement, okay, in the same project. Okay, and the third triangle is about what we are selling. So which are the trends here about in the robots? So obviously sensors, all about sensors, including safety, 3D safety, low cost 3D safety, and low cost. All the combinations of these three items are trending, okay? Then in terms of fleet of robots, a trend is multi-brand, okay? So some integrators want to combine different brands of different robots and mount a fleet with different robots of different brands. Why not in a decentralized way? Okay, so adding or removing robots should be easy. And obviously in terms of fleet, the cyber security, which means the security of the machine, okay? And then in the last one, the most scientific aspect maybe is the algorithms. So obviously there are still localization issues, not solved or not well solved. There are still object recognition issues, not well solved for the industry. And to provide the robots with a higher understanding of the scene, to reason in a better way is also a trend, okay? So, and just one slide about my company. So we sell a full software stack for mobile robots. Full means from low-level control up to fleet management, okay? And these are some robots that are running our software. You see it's mainly industrial AMR, so autonomous mobile robots, that built by engineering companies or robot manufacturers that trust on our software. Okay, so thanks a lot, and open to chat after the session.
Okay, thank you, Andreu. Thank you very much. So now we open up for Q&A from the audience. If anyone has any questions for the speakers regarding their products, their services. If not, we will continue to the coffee break. Is anyone having any question? Well, we are on time. Well, if not, I'll go with one question for all of them. What do you think are the main challenges for the implementation of this technology in SMEs? I mean, I imagine there are like security challenges. Also, it's more a matter of the integration with the current systems. It's more a matter of money. What do you think are the, I mean, you can ask whoever wants, yeah. Okay, Alex? Okay, perfect, yes.
Thank you. I should say that building trust with the small and medium companies, but I give the microphone to Kurt to answer more deeply this question.
Thank you very much. Actually, we've been doing.
You can stand up,
yes,
please.
Sure.
Yeah, Kurt.
So actually, we're seeing a number of surveys on this topic as well, and I think the number one every time is lack of time. The financial part is actually coming a bit lower, so it's really about having the time, and I think time is of course also a part of knowing about the opportunities. So increasing awareness to show that the robotics is really important and can be a game changer for the company's business is really important to make sure that they prioritize to have the time. So at least that's what we see in Denmark, that lack of time and lack of knowledge is the two main reasons for not taking these technology in. So it's not really about the technologies, it's not really about the business case, it's really about making sure that the one who can benefit from it know how to do it.
Okay.
Thank you.
Perfect. Thank you very much. So now we go to grab a quick coffee if you want, okay? Okay. Thank you very much, everyone. So hope that everyone is more energized now and prepared for this second part. So let me introduce you the second part of the event. Now we will have presentations from the Shafir network. We will have, I think, 5 spin-offs explaining their products and their services, and 5 research groups from the Shafir network explaining their transfer technologies. Please, I ask you to be strict with the time. In 10 minutes, we have to move to the next, okay? Because we have very limited time. So after this block, we will have a time for Q&A. And having said that, let me welcome to the stage the first spin-off, Alicia Casals. She will explain her spin-off, Rob Surgical. Alicia, she is head of the Robot and Computer Vision Group at Center of Research in Biomedical Engineering, CREP, part of Green's UPC, the Intelligent Robots and Systems Group, and she is president and co-developer at Rob Surgical, the first Catalan surgical robot. So thank you, Alicia. Big round of applause. Thank you.
Okay. Thank you.
It is working? Yes. So the floor is yours. Thank you, Alicia.
Okay, thank you. Thank you very much. Okay, I'm glad to be here to present the main ideas of the way we have done and where the company comes from. So I will start with a little background and then see how and why we start with this company and where we are. So basically, as a background, we have a long time of experience in working in surgical robotics in different areas. We start with laparoscopic surgery and with orthopedics or maxillofacial surgery, which are different specialties. These are always lab, most of them are photos of pictures of the research in the lab. But we did our first intervention in a real clinical situation in 1996. We started at the earliest 1919 working in the surgical field. We had some experience in assistive robotics. And a surgeon came to us and said, if you can solve problems in other areas, you have also to help us in this area. So we start. And this was the first and a real intervention. In reality here, the robot was not doing an intervention. It was just holding the camera. You know, in laparoscopic surgery, the surgeon managed the instruments, but also an assistant is holding the camera. This was what the robot did by that time. But then we continued the research here. Here we have the lab experience in which, as you see, here this was an industrial robot that was used by the time. in order to be able to do this experimental phase. But then, if you want to go really to the operating room in real situations, you have to have specific robots prepared for that. So we did this kind of crane robot that is able to be on the operating bed. Then the next step, this was maybe at the start the easiest part, that this was just holding the camera, but then robots became too advanced and say, let's use not only the robot for the camera, but also the robot to manage the instruments. So by means of teleoperation, you know that we can improve the performance of a human. So the robot is replicating what the human is doing, but contributing with some assistive parts. So in this line, we have been developing different research in different kind of interventions. You know, in this laparoscopy, we need several arms. In this case, only one, depending on the application. This was for fetal surgery, a background or a scenario we do to develop these typical strategies. But let me just put an schema to situate the surgical robotics. There are quite different situations. No? This is a programmed robot, like in radiotherapy, that everything can be programmed. But then we have, you know, the Da Vinci, that is the most popular robot in surgery. When we refer to abdominal area, this is so not programmable, so it can only be teleoperated, in this case with these 4 arms, or co-manipulation in this sense. Final video. In this sense, the human and the robot are manipulating. There were not collaborative robots by that time, but the idea is that the human and the robot cooperate. So it's the assistance that we can have in the operation, we can have also in this co-manipulation. In this, we can put these artificial sheets to protect the areas and add all aspects that we have. And the way to autonomous, this is a project that we have just finished, just to say that we are very far from having an autonomous robot in surgery that is doing very, very simple assistive tasks, like while the surgeon is operating, holding an organ or something like that. So this is a very, very slow way to this. But then, from this background we have, how we came to create a company. We had experience in other companies and other not so complex companies in our group. But the spark was one visit to Mayo Clinics in Phoenix, Arizona, that we were invited to present this, let's say, this software, these control strategies for assisting in surgery. And well, the outcome of this visit to this group was, if you can do this, I want to buy robots from you. So we came back home and say, they want the robots, what do we do? And we decided to create a company from scratch. So by that time, we had nothing except our experience in programming robots, industrial robots, in the lab. So at the beginning, and we had the competence, and this Da Vinci robot that I put here, this image just to see that is the first robot that has wide expansion and wide acceptation, but also many complaints because they wanted to buy our robots because of the limitations of the current robots in the market. So it needs improvement. So we decided to go for that. What were the first steps? So the idea is a search of technological and business partners, because we were just university professors and researchers, and we look for this. And as a starting value, what we had is the experience on using these standard robots, off-the-shelf robots, for developing our systems. So we look for robotic companies, technology centers, institutions to try with us. I was at that time at IBEC too, to create something, and we were expecting that companies in robotics would like to invest in such a project. But at the end, what we found is that they were not interested in investing in a new robot, but just in having common projects. So after some years, we decided to start ourselves. And we decided by means of the development, the projects we had, to start to build and design and build our own robots. So we were the three of us in front of a monopoly starting for that. And we built this first prototype, and with this prototype, that is a column with 2 arms, the idea was to have a modular system with, because now Da Vinci has 4 arms, and sometimes we say maybe they need even 5 arms. So the idea was to do something modular like this, but at the end we came back to the 4 arms as Da Vinci. What were the steps? So after having this first physical prototype and pushed by the university to do a business plan, etc., we had the first presentation to friends and family, and we got the first amount of money to have something, to have an employee, and to start. Then later on, we had the second round already with real investors, not very big, but a little bit more. And a third round, and at the end now we have a big investor, so we can not worry much about money, but on the developing the system. So this is the robot we have built. This was the version of with 3 arms. And the concept is try to improve the performances of current robots, and with this lemma, universalizing high precision surgery, being much more, as you have seen, Da Vinci is a robot that is invading all the operating room. Everything is around the robot. So we want to have the robot as an additional instrument that can be used, can be moved apart when not necessary, and be much more flexible on that. But looking at the project, we have really 3 big projects. One is the robot itself, this is the new version, with the 4 arms. The other is the instruments that are really 3 degrees of freedom robots, but micro robots, so even much more complex than the robot itself. And then we have the console for programming it that has to be very soft, with a very transparent teleoperation, and that is like another one project. So we have these 3 big projects, and this is the present robot. As I said, we have created the concept of hybrid surgery in the sense that can use manual laparoscopy or robots, because we can move the robot apart. Da Vinci takes about 20-40 minutes to prepare the robot before the intervention, so it's impossible to say move the robot apart and then come back. And that's, I think, is a very good performance we offer. We can operate with different systems. It is open, not like Da Vinci, and we have this quick setup. So preparing everything is very quick, and have by now some performances like camera guidance automatically and respiratory motion compensation as one of the first performances. It's quite difficult due to certification, add more performances, so this will take more time. So we are now in the process of certification. Picas la video? This is just to see the robot moving. This is not the old version, but at least you can see how it operates. So the idea is that we have designed specific joints, passive joints, that has allowed to improve much more the performance and the mechanical complexity of Da Vinci. And in that sense, we think we have done a step forward on it. So you see, this is a kind of interventions, and this is impossible to program. That's why we have to rely on teleoperation. But the idea is in the future, when we have certified and sell, because we are still in the process of certifying, being able to add more and more performances on the way to make more even autonomous parts, like suturing. And this is the part of the robot operating here in all these preclinical phases in which we are now continuously operating small pigs. And so we are now in this competing. We started several or many years ago with this idea. We had only as competitor Da Vinci, but now the growing market of surgical robots is increasing. We have here robots with one column and the 4 arms, as we see here. These are other robots, but we see that even some of them are already certified. They don't sell because conceptually we think that having 4 independent arms occupy everything, and I think it's almost impossible to work in the operating room in a practical way. And these are particular single port, so are specific robots. So we are in this course to the market. We will certify next year because this is a nightmare, something that never ends. But we think we are now in the good way and planning to do very soon the first human real intervention. Thank you very much.
So thank you very much, Alicia. Very interesting presentation. And now we have from BICOROB, that is a research group from University of Girona specialized in computer vision and robotics. We have here Marc Carreras, CEO at Equa Robotics. Hello, Marc, good morning. Thank you. Okay. Thank you.
Okay, thank you very much for the invitation. In our presentation, we'll explain the work we have been doing in the University of Girona in the creation of a company called Equa Robotics. You can see it here. Okay, so it's a spin-off company created in 2016, so 5 years old. We basically design and develop underwater robots, which are autonomous, so autonomous underwater vehicles. And also related equipment and software in order that these vehicles do their job. So right now we have a team of 15 people. 8 of them we have the PhD degree. So as you can see, there is a lot of knowledge there and a lot of know-how on how to do the things. And basically, the kind of robot that we develop is a robot for research centers for universities. So this is the way we created, the way we found the first customers, and the way actually in which we are already right now. Here you can see also the values of our company. A lot, it's based on innovation, a lot of quality in designing the technologies, but also in giving a good service, technical support to the customers, using highly trained talent from the university and from other places where we can attract people. And of course, our robots are for the international market, and we also have as a value of the company to try to grow progressively. So these are the vehicles that we develop. These 2 vehicles were designed at the University of Girona. So the company was created for the commercialization of these 2 AUVs. The one on the left is called Girona 500. The one on the right is called Sparus 2. So these are vehicles that are basically used for mapping, for going under the sea and reaching the depth of 500 meters or 200 meters, depending on the model. And once they are there, they can be equipped with a lot of kind of instruments, cameras, sonars, communication systems, and so on. So to go there and to map the underwater environment. Our vehicles are conceived to be very open, so they are based on ROS. And they are, and we explain and we train our customers in order that they are able to integrate new equipment and to develop and to test and to use it in their own research projects. So, for instance, they can integrate their own, they can modify the vehicles. You will see now some pictures in which you will see how from the basic platforms that we develop, they have been able to modify them. So we develop also the software required in order to control these vehicles. On the left, you have the graphical user interface that is used for programming missions, for following the UVs when they are underwater, for communicating, and also for adding the maps that the vehicles can create. And on the right, you have also some software that we have developed for creating maps, acoustical maps that AUVs or using other platforms, you can acquire some images, and then you can create these acoustic maps with the software on the right that is called Sound Tiles. So these are the customers that we had, the origin of the customers that we have built since the creation of the company. Right now we have sold already around 15 vehicles. You can see here on every year more or less the production that we could do. As you can see, is very small scale production, but we have been able to sell these AUVs to basically European countries, Spain, Germany, UK, but also to Israel, to South Africa, Republic of Korea, and so on. And this is the trend that we are having. So here you can see some images of the AUVs owned by the customers. So this is, you can see how they use it. For instance, on the left, you see a picture in which a customer has two of our platforms, and they have it there on their oceanographic ship, and the vehicles are prepared to dive and to get images from the seafloor. Also on the right, you have several images on how they use the smaller vehicle, the Sparus 2 AUV, from small boats, or even they use it inside water tanks for testing and for developing their own research projects. So this is this is how our vehicles, our products are used by our customers, and you can see here how they did it. And here you can see a sample of some of the data that the AUVs can acquire from the seabed. So, for instance, on the top left, you see Sparus 2 in a modification as a modification prototype that one of our customers did, adding lights, adding additional propulsion. And also on the lower right, you see left, you see also Girona 500 with a set of lights in order to correctly illuminate the underwater scene. And on the right, you see different images from the seabed at different depths, using optical cameras and also using acoustic cameras and sensors that can be used for creating 3D bathymetries or for creating acoustic images or mosaics from the seabed that then can be used for inspection and for mapping and for knowing what is present in the seabed. So now I'm going to explain our history, how we created, how we were able to work during this time. First of all, I start by the previous steps that we did. The previous steps were all the work done at the University of Girona in many European and national projects in which we developed, we designed the vehicles, the prototypes that you can see there. And then also we participated in a lot of competitions, European competitions on underwater robotics that allow us to understand very well what the users and what the vehicles required in order to be useful for other teams. So this here I put the last 10 years more or less before the creation of the company, all the things that were done at the university for doing this. Then we created the company. The university gave the license to the company for commercializing these two AUVs. And then from them we have been able to slowly, step by step, growing and being able to build and to participate in many contracts and also in many research projects, as I explained before. So in 2016 we created the company. 2017 we did our first delivery. So this is this might be different from other spin-off companies that that require a lot of time in order to do the first sell. In our case, before creating the company, we had already the customers that wanted our platforms. Remember that our customers were other research universities that had the same requirements that the vehicles already had. So that was very easy for us to, just after creating the company, being able to deliver the first prototypes. So in 2017, we did our first cell. 2017, we were also, of course, continuing producing and delivering the AUVs that I explained before, but also we were able to get grants for employing people, for funding the company in European, doing the work required in European projects. And you can see here the evolution of the things that happen during these 5 years. Then, just for finalizing the presentation, some recommendations or lessons learned that we can say from the creation, from the experience that we had in this company. First of all, the team. The team is the most important part of the company. In our case, we could attract many people from the university that were finishing their studies there, their PhDs, their degrees, and that's the most essential part of the company. Of course, in the new team that you create, you need not only to develop the technologies, but also to manage the company, to do all the processes for selling. So for this fact, the soft skills that you need are not the same that the one that you have in research institutions. So here you have an important work in adapting and getting new people that can help you and adapting new skills that maybe at the university are not so required. Then from the licenses that you got till commercial products, there is a very long way. There is a lot of things to do, and this is something quite hard that we had to do, and actually we're already doing for the new products and for the new developments that we are doing. Another thing is that the company must sell. It's not only to develop new products that are cool, but also new products that can be sold to someone. So it's very important to study very well what the customers want and to give them the product and the technology that they need. And then another thing that is very sometimes difficult to decide is that when you create a spin-off company in underwater robotics and with all the calls at the European level for participating in European projects, you get many requests from many consortiums that want you as an SME to participate, but then you need to focus very well on what projects you participate in order to focus the development that you will do in that projects, depending on the roadmap that you want to follow, and not just participate in projects for participating, which can maybe not focus on the things that you have to do and on the steps that you must do in order to grow and to correctly create the products and the line that you want to follow. And that's it, more or less. This was the things I want to explain you. Thank you very much. Okay,
thank you very much, Mark. Very interesting. Also for any researcher of the Shafir network that wants to develop a spin-off. These lessons learned are also very interesting. So now we have also from Vico Rob from University of Girona, we have Josep Forest. He's CTO at AccurSense, okay, a company that was sold to Cognex Corporation in 2016, and now he's also co-founder at Opsys Vision Technologies. Is that right? Yes? Okay.
I think so. Thank you very much, Maria.
Thank you.
Okay, so actually I'm here to talk a little bit about the past. This is a story past. It had its start point, it has its time for development, and then it had its end, okay? So more or less.
Is the micro working? Is it working? I'm not sure.
Closer, okay. Now it's okay? She's? Okay. So, yeah, just to start. We had in mind back in 2005, we started with the idea of, well, we had some good experiences and some good results with different PhD works that we had regarding 3D machine vision or 3D computer vision at that time. So we say, okay, why we do not only leave these into a drawer and try to commercialize the kind of things, and let's try to focus our attention in finding some useful way of making someone else to be aware of this technology and to use it. Okay, so we started the company with the aim of commercializing 3D acquisition and processing technologies for the 3D machine vision market. Okay. Back in 2005, 3D was something that everybody had in their mouth, so everybody was talking about 3D, but also very, very seldom and very little people was really using it as something that really was deployed in a standardized way, meaning there were, of course, there were some companies that had been in 3D for many years, but the market share was really limited. I mean, it's not like there existed several different options for purchasing standardized machine vision libraries such as Halcon or other existing ones that were there. So we thought that we might probably succeed in producing such a thing, okay? So to this end, we established a business model in two great fields, okay? So we said, okay, we want to be the suppliers for this kind of standardized machine vision, okay? But still, we are going to keep ourselves and try to sell also our expertise to OEM and machine builders, okay? Keeping on with, okay, let's do something that is not a standard product, but let's also help other people to also incorporate this technology in a way that probably with our experience, we could maybe give advice and actually try to promote the success for this. I gotta tell that this second point was the most successful one rather than the first one. We kept trying with the first one, of course, but most of the sales came from the second. So we actually became a kind of reference in the field for very particular manufacturers. I mean, not in the mainstream, meaning that, okay, everybody wants to buy our library to do their products, but interested customers would also knock to the door and ask for our help, not only for, okay, we want your libraries and your expertise to incorporate that into our products, okay? And some examples of them are, among others, I just kept myself very lean on this, but manufacturers of dental scanners, for example. I mean, this technology at some point started to evolve into something that today is called the intraoral. So it's something that you go to the dentist and they tell you to open your mouth, and then they put something, a scanner that can partially reconstruct your teeth. But still, the need for something that is really, really very accurate and lower cost, as usually. For scanning your teeth and getting your prostheses to be manufactured in a way that they can be easily and comfortably accommodated in your mouth was something that actually was, and still is today, an issue, okay? Because there's some point in there, you want to scan it with a very, very, very high accuracy, but then the process at some point needs to be manual, okay? So maybe today it's a little bit changing with the additive manufacturing that back there didn't exist in the way that it is today. But we helped several manufacturers to come up with this kind of product. Also, we helped different camera manufacturers to incorporate. I mean, today we can find different camera manufacturers that claim that they have the so-called 3D triangulation, laser triangulation cameras, okay? So they need to have the algorithm for detecting the laser line inside, and we helped at some of those manufacturers to actually obtain their product. Okay, now they've been in the market ever since, and they're still evolving. Photon Focus is one of the examples today. Okay, so this is what actually AQSense was about. Actually, this was our dedication. These two examples actually summarize very much Imagine other fields like automotive, other fields like robotics, and other fields like quality control in different markets. You can imagine the sort of activity we used to have. So a little bit talking about the history. We were born as a company in 2005, okay, with this happy idea. Probably the history is a little bit some of a standard. I always like to say we were very good at, I always say, if something can go wrong, it will go wrong, okay? So if you potentially can do something wrong, you do that thing wrong, okay? So I like to say, we did everything wrong. Well, maybe not everything, okay, but we did a lot of things wrong. And that also provided a lot of good experience and a lot of good things to go ahead with other projects, okay? So the company actually was like 11 years alive, okay? During these 11 years, after we were born, we needed the first capital round. Actually, it was not the same case as we didn't have any customer whatsoever at the very beginning, so it's we came up out of the blue with a happy idea, and we started to go to trade fairs and showing up ourselves in little stands and explain the technology. People actually came and were very interesting, but sales didn't actually come. So we started to ask for rounds and started to try to find venture capitals and so on. Okay, we had patents, we had articles, we had technologies to show, but customers didn't come, okay? So we started a second, let's say in 2007, 2008, we started in a kind of another round looking for business angels. We obtained a neotech, a venture capital. Venture capital came in addition to the business angel. Actually, going back a little bit to the presentation that Mark has just did, the very good thing is you actually need to incorporate somebody in management at the very beginning. So this is probably something, if some of you is interested in going ahead with such a product, somebody from management, somebody that probably doesn't think in the same direction or in the same standards that we scientists do, is really positive. You want to have these guys inside, because otherwise whatever you think is jeopardized from the very beginning. Actually, that view needs to be there from the very beginning, okay? That's probably one thing we realized probably too late, okay? But nevertheless, it came eventually. The team started to grow. We became pioneers in artificial intelligence and 3D. We started to gather customers. We expanded to different markets and fields. Again, not so much in the standardized way, very much in the specialized. Okay, so actually being suppliers for very, very specialized customers. Okay, so everything went on from 2010 to 2015. Things were more or less the same last year. 2015, first acquisition proposals and due diligence and all these kind of things started to come, so people were really interested. Actually, 10 years after, the market really wanted to start incorporating standardized ways of dealing with 3D machine vision, change from computer vision to machine vision, which is the term that usually is employed more in the field in the industrial field. The thing ended up in 2016 when Cognix Corporation came, knocked the door, we started talks, and it really was really easy to understand everything with them. So the acquisition was something really, really smooth, and it went really well. And now there's the same people that was involved, all the workers that were involved, all the specialists and were involved in the development of all the EcoSense stuff is today still living in Girona and working for Cognix Corporation in there. So the team was there, and it has done nothing but growing and developing new technologies for them. Okay, so from this perspective, I'm quite glad. Maybe from other perspectives not, but this specific one it's really good. So I have already mentioned something, but for lessons learned. Being the first does not always imply having the best options. I mean, you can be the first one into something that, okay, you sort of have got the glimpse that there might be a need for that. You do your market research studies and everything, and in the end, yeah, you get positive feedbacks, but okay, nobody dares to be the first in applying such things, okay? So it's kind of, okay, let's see. Yeah, you have a very good thing, but yeah, okay, let's see. Is there any other that has it so that you can tell me? This kind of things exist. Capital investors, whatever is capital, you have to have this very clear in mind. Only understand money, period. Everything that is related to whatever your idea is and the customers, and you want to do that because I like it, forget it, it's money. So if money comes along, that's a good thing. If money doesn't come along, then probably you don't want this kind of funding. Maybe you want to go for something else, okay? But if you want to do something that have to make a path in the industrial field and want to sell something, then everything has to, in the end, be translated into money and big figures, if possible, of course. So that's very good to keep in mind. Good business idea is always a balance between a good product and a good marketing and investment plan. Again, managing has to be involved at the very beginning, and if possible, before. So you start working before you do your own company, but start working very, very hard, especially in this field here, because this can change your first or your former idea about how to orient or how to look at your idea. Maybe the product as you thought at the very beginning was not exactly what the market wants. So you want to really make a research on the market and see how you face everything before you actually be in the market, okay? And well, this may probably be something general, but problems must be faced, never buried. Never bury a problem, always face to face. If you have a problem, you must deal with it and solve, whatever the outcome it is, but you have to, okay? Okay, recommendations. Well, having lived that, yeah, probably some recommendations are at hand. So, yeah, make sure you have the power when negotiating capital. So don't go there with your empty hands, okay? So good product is not enough. You don't have to, you don't want to go to a capital investor with a sheet or two of papers and trying to, or imagining that you go there and do the elevator pitch and the guy's gonna trust you and they're gonna give you a lot of money for developing your business. That doesn't happen actually very often, actually. But also don't go there with your empty hands, okay? You really have to work a little bit or a lot before you go and ask for capital. You really have to show figures that are real, and your figures must be backed by someone that actually understands the figures, okay? So meaning, okay, I mean, this prospect, this guy is a very good customer in the field of whatever, automotive or health, whatever the field is, but the figures must be backed, okay? And once you have that, then you have power. And when you have power, you negotiate with your hands full, and that's an advantage. If not, they will take all. That's the whole thing. Again, get the right people involved. You need good workers, but you also need good shareholders as well. So people that in some way they have to contribute to the company, right? Meaning whatever is your skill, it doesn't matter how many hours, how much time you invest in it, but they need to be also key figures, even though they are not probably directly involved in the company, in the work or everyday work, but the shareholders need to be something special within the company, okay? And the other obvious thing, but sometimes it's not so obvious, so keep cool and don't bore yourself out. This is really, really easy. This thing is what happens the most. And burning up means, okay, to hell with everything, I dedicate my life to something else. And then the whole invention goes away. So just try to keep cool. Do not actually overdo whatever your activity is, okay? So, that was the story, Maria.
Thank you very much.
Thank you for listening.
Big round of applause. Thank you very much. Perfect. So now we have Alberto Ren, also from Bicorrop University of Girona, and he is CEO and co-founder at Opsys Vision Technologies. Thank you.
Thank you.
Thank you. The floor is yours. You have. Thank you.
Thank you. Thank you for the invitation. I'm Alberto Ren, CEO and co-founder at Opsys Vision Technologies, which is a spin-off of the University of Girona, also from the Computer Robotics and Vision Group. Opsys was born in 2016, 6 years ago, but to understand why Opsys was born, we have to go a little before. Around 9 years ago, we started as researchers in the Bicorrop group a project with Alstom Transport that they want a train scanner. Okay, they wanted to develop a complete scanner composed by multiple 3D scanners to get all the information of a train which is scanned on service. Okay, so we had this on this project, designing and developing the software to acquire and process all this data. So we developed a prototype which was built on Manchester, composed by 20 scanners, which completely scan all the underframe and the sides of the train. You can see here an example of a real data scanned on Manchester with 2 scanners, composed by the 2 scanners of one side. This is a complete bogie. And with all this data, we can get all the information of the train regarding the wheels with the diameter, the patch thickness, any antenna, if it is missing, if it is damaged, if there are bolts, screws, etc. missing. And it is doing on service, on the workshop, without people on the train. But the idea is they don't have to stop the train. It is only passing through a canopy, and they gain hours and hours of service, which is the great gain. So the prototype was developed, and it was developed with success. Okay, so from there, it was a technology transfer project. So they have the intellectual property of the technology, but we had the know-how. And they wanted maintenance. They want to develop new train scanners with modifications, with updates, etc. And they asked us to continue doing that work, which is not work that can be done from the university, which is far from the research. So we decided to create a company to do that with all the team involved on that project, and it was Opsys. Of course, we are not only providing this technology to Alstom. We have increased the work to other sectors. Okay, we are mainly providing 3D machine visions for machine builders to incorporate a vision system to their machines to include quality control, metrology, the defects, etc. We are mainly using a 3D technology. Well, I have not said, but we are held in Girona, in the technological park of the University of the Girona. And we are a multidisciplinary team. We are now 7 people, 3 PhD, which is because we do a lot of research, 2 engineers, and 2 people on the management and marketing department. Okay, we have developed our own software 3D technology. We have our own 3D libraries for the camera acquisition, the 3D reconstruction, and the processing. So we don't rely to software from others. And we also design our own scanners. I mean, we typically use a laser camera system, which is one laser in a plane and a camera looking at the laser, and with the movement we can achieve the 3D reconstruction of the element. Here is an example, which is composed of 3 cameras and 3 lasers and a coil. So with the rotation of the coil, we can get the 3D reconstruction, and from here we can detect if there are any defects on the thread or even the brightness or marks. Okay. So we are mainly focused on 3D, but we also have 2D vision systems, and we also include artificial intelligence and deep learning to the processing part to get the errors, the defects, etc. You can see here one of our 2D machine vision systems on the web industry, which is evaluating the printed tickets that you can find on a plastic bottle, for example, and it's looking that the motif is correctly printed, and in particular this machine is scanning at 400 meters per minute. So that's what we are doing. And to see a little history of this our short life, okay. As I said, the spin-off was created on 2016. We had one client and one important client, so it helped us a lot, and we can start well, maybe easier than other companies. But of course we couldn't rely on that, and on 2017 we increased our workforce and we opened it to other clients and other sectors. So we were increasing our work, and very important date for us is 2019 when we moved to a bigger office. It was not a very far movement, so we moved from door 3 to door 4. But we doubled the space. So for us, it was very important. Okay. Then that's not the expected, but it arrived COVID-19, as everybody knows. It's not a good key milestone, but for us it's also important because it changed us, because a lot of projects stopped or even were cancelled. So it shocked us a lot, but well, we redefined it a little bit, and we are still here, so it was not so bad. And now we are seeing the things better, and we have started the 2022 with a new business plan that we think that will help us to grow from what we are now. We have increased our workforce, incorporating a person who is dedicated to the strategy of the company and the management on the short terms and also on the long terms, where want to be in the future. And we also have increased the workforce on the research and development, which is the soul of our company, and we don't want to lose it. And well, we are now starting on the research and development of our own scanner instead of using shelf of the component lasers and cameras. And well, we expect that next year have the first prototype. We are a little bit optimistic, but okay, and well, I finished with some lessons and what we have learned from these years. Maybe are obvious, but I think they are important. The first one, it's said that marketing and sales as important as a good product. As researchers and technologists, we thought that having an excellent product is enough, but it is never enough if the clients don't know that you exist and you have this product, it doesn't important how good it is. So you have to do good marketing and sales strategy. The second one is the first that we learned, that time is money. Okay, as at the beginning, all the members of the team were partners, so we have the idea that all the hours that we spend there are free. It doesn't matter, but that's not true. Every minute you dedicate to the company is important and must be computed. Okay, because it's your time and the product costs your time also. Okay, and the last one is that you have to never stop. Okay, even when the things go well, you have to still working on improvement, research, etc. Because the competence is always doing that, so you cannot stop. And just to finish, some recommendations from my humble point of view. The first one is very obvious, and it has been said before. Surround yourself with the right people, good workers, but also good people. Okay, you have to build a team. The second one is believe in yourself, because if you don't believe in yourself, anybody else will do that. So you must be good, but you have to believe that you are good. And the last one is that you have to learn to separate family time from work time. Okay, as entrepreneurs, we tend to spend a lot of time to our company. And I think, in my opinion, I think that it's more important to separate family time than work time than the time you dedicate to each one. Because when you arrive home and you are with your family, you need to forget the company for that time. And that's not easy. And I have not done yet, but I'm keep trying. And that's all, and thank you.
Okay, thank you very much. Thank you very much. Thank you, Albert. Now we have David Caballero. He will present his spin-off steering machines. He is from the Center for Industrial Equipment Design and Dynamics of Machines from UPC. Okay, thank you very much. Thank you.
Okay, thank you very much for inviting us to this event. We are very glad to be here with all of you. As said, I am David Caballero, and I am here on behalf of the Center for Industrial Equipment Design to talk about a little bit of the center, but especially of our spin-off steering machines. The Center for Industrial Equipment Design is a technological innovation center of the UPC. We are located in Barcelona, in the South Campus, and we have 20 years of experience performing actions of technology transfer with different local companies such as Girbau, Comexi, Giro, etc. Training actions in two ways, on-demand training, but also in a master degree, MA, and also research especially in the lines of robotics, mechanical design, and sustainability and energy efficiency. So let's talk about the technology that we have developed. MOBI is a mobile robotic technology that can perform omnidirectional movement, omnidirectional trajectories without the use of mecanum wheels. We use conventional wheels, and this is the value proposition, or the first one at least, that we provide. I guess that most of you are related with, or you can understand what omnidirectional movement is, but just in case, I wanted to add this video that shows how a omnidirectional mobile robot performs omnidirectional trajectories, and what's the key of that. The key is this, among others, advantages. We have a full maneuverability, which eases the control. We have introduced space and energy optimization. And last but not least, natural interaction with humans. To explain a little bit more the last one, humans, we are omnidirectional, so we move omnidirectionally. Then when we want, or when we interact with robots, it's easier if both of us, we are omnidirectional. And then on the side of the advantages of conventional wheels instead of mecanum wheels, we have that conventional wheels can ride on any surface in all terrain, so we do not need a very flat surface to work. It have a higher load capacity, and they introduce lower vibrations and low maintenance compared again with mecanum wheels, which are the ones in the left. Well, this is our history or our timeline. The first prototypes and tech validation, we are going to see some videos afterwards. Start on 2017. Then we moved to IPR protection in 2018. We asked for a European patent that we achieved. And currently we have also presence in different countries worldwide in IPR meaning. The spin-off was created with the name of Steering Machines in 2018, and then two important milestones for our growing and for our developing were that we were awarded by Barcelona Activa as a best startup in 2019, and in 2020 we were awarded with the most promising industrial startup by IQS Next Tech, and they provide a lot of resources for keep going. Then the industrial products and success cases, and in 2022 I want to show what are we doing now and our research lines. Here, what I like to add these slides is the way in the prototype side. So from the very beginning, as you can see, it's a very simple prototype with 3D printing technologies, and just to test that the technology makes sense. Then we move to a little bit more elaborated prototypes. This one has to or can carry up to 200 kilograms of payload and start to perform these trajectories outside in not flat surfaces. And the last one is a test inside the university that the robot is delivering parcels around the Faculty of Mathematics and Statistics, and well, avoiding obstacles and going to the final point. Then moving to more industrial products. These are Mobi 500, 1000 and 2000. These are the payload capacity of each model. And I want to say here that these are not final products. So the value here is that we can choose between different layers already developed for fleet management, navigation system, and the customized external body can be also performed. In this case is a pilot test in Comexi with a tailor-made outdoor body. This is another success case, Tandem in collaboration with Andreu from Beta Robots and IDASA. Behind this structure there are two Mobi 2000 collaborating and working together synchronously to carry up to 4 tons of coil with, in this case, a roller conveyor on top. And well, we are very proud also of this product and this collaboration. Right now, what are we doing? What can we offer together with Steering Machines and SEDEI? Combining the two parts, we offer this customizable or tailor-made solution, combining the omnidirectional movement with any other application that wants to be installed on top. As an example, roller conveyor, lifting table, or robotic arm. And yeah, a part of this presentation, I wanted to show our research lines on robotics side. We are working on mobile manipulators, especially on the dynamic sides, trying to combine the dynamic of both elements, the robotic arm and the platform. And try to make them work together as a single device, as we do when we perform any activity. On the mobility side, we are developing and trying to move to outdoor applications for agriculture or construction. This is this AgroMobi device, and the last development that we are working on is this robotic leg for quadruped robots. It is a modular leg, and I think no, there was an image there of the current. But I don't know why it's not here. But we have developed and constructed and assembled it recently, 2 weeks ago, and we're starting to do tests with the leg. Yeah, this change actually we have done it because of we saw, as you said, Francesco, before, that wheels are not for everything. So we cannot climb stairs without having legs, and that's why we start moving to this line also. And finally, the lessons learned, some of them are shared with other spin-offs, but the technological development is expensive. So every prototype that we have seen, even some of them were very basic, but they need money, and it's the difference, very strong difference between like software company and technological company. Incubator programs, as said before, they help us a lot. Also related with this 4 point, that the technical knowledge is needed, but it's not enough. We have very strong background in technical part, but we were not that strong on marketing, on sales, etc., and is where incubator have helped a lot. Innovation has to be client-oriented, that's obvious, and it's nothing more to say. And the team, we agree on that. The team is important, to have a strong team and really motivated team to go further. So that's pretty much everything I wanted to say, and thank you very much for your attention.
Thank you very much, David. Thank you for your presentation. So you all agreed with some of the lessons. The team is important. This resilience part of never giving up. So also time is money, you said. So I think this can be really helpful for all the researchers that are listening to us. And now is the part of transfer technologies from the groups. Now I'd like to invite you to the stage, Francesc Cortés. He's principal researcher at the Robotics and Automation Unit of Leitat, and he will talk about new processes and tools for industrial robotics. So thank you, Francesc. Thank you. I don't know if it's on. I have to switch it on. Okay. Thank you. Thank you. The floor is yours.
It's on, no? Yeah, now it's working. Okay. Well, I'm not a spin-off, of course. We are a technological center, but you will see that we have many things in common. So the examples I will now present really has some coincidence with the elements you have already presented today. Okay, I will present only 4 success stories. I didn't want to go deeper. We selected 2 past stories and 2 actual stories to present what we are doing in Leitat as examples of our activities. So, one is a metrology example. This is very similar to AcuSense example, so you will see. The idea was that some years ago we had contact with a company that is doing contactless metrology. They are using area measurement system, so not laser, but white light and area measurement system. At that time, there was no clear equivalence between the CMM machines that are the standards in the metrology area to the contactless system. So there was a gap there to really be able to certificate that systems were able to do the same measurements as the standardized systems in the automotive industry. So what we did, we had the initiative to make a project together with Nissan here, close to what we are today. Sadly, not longer here, but it was here many years ago. This startup company, Noob 3D, a robot integrator, and LATAT. This project was executed in Nissan in a real workshop, and we validated this project in a pilot cell in Nissan. Well, really, we did 2 pilot cells, but okay. At the end was the pilot cells you can see in the middle, okay? Results of the project. Well, the project worked. We were able to demonstrate that the system was comparable to a CMM machine. The system has the possibility to calibrate itself each cycle, etc., etc. So it was comparable to and at the end of the project, ABB approaches Noob 3D to make a joint venture to sell meteorological systems to the market. So they created a functional package that ABB and Noob 3D offered to the market. That was no longer ABB LATAT in the picture. So the business success is not ours. It's ours because we had the initiative to see the potential of this technology. But at the end, of course, the companies is the ones that are driving the success of the business. So finally, ABB approached that company, and finally ABB acquired the company, I think 3 or 4 years ago, the same as Cognex acquired EcoSense. At this moment, all the personnel of Noob 3D is ABB personnel. They are running the technology inside ABB by themselves, so the same people is developing and running the technology. Now, in a worldwide market, because the ABB, of course, has reached in a worldwide market, and now this technology is widespread in all around the world using the Noob 3D technology. Well, okay. The next example is a very close example. You can see downstairs. We started with a project that was called Smart Factory. At that time, 3D printers were used to create prototypes and so on, and we believe that it could be used to create end effectors for robotics. So there are some pioneers. We are not the first ones that did this, but we started to measure and investigate how can we do that. So at the end, we make a project using additive manufacturing, and the goal was to make the gripper as a single part, not just anything else, that just a single piece. And we succeed. There are many. This is the very first prototype. You can see that. I think there is a video. I don't know. Okay, later is a video. And then this grippers has, okay. Yeah, run the video. That's okay, perfect. Well, this you can see that live in the lab if you want later. The advantage of this system is that it's very easy to use. It's very easy to print. You don't need spare parts to have a spare gripper in your workshop. You just need the 3D printer and print a gripper, and that's all. And the big advantage is that this gripper is much lighter than a conventional gripper. So this gripper typically is from half to 1/10 of the weight of the equivalent mechanical gripper with parts. Okay. Of course, this is HP. The idea and the development is like that. And you can see all around the world in HP booth in all the fairs, and no mention to like that, but the gripper is like that development, okay? Okay, this is the past. Now the future. Again, steering machines. We are running mobile robotics, and we are doing dynamic and kinematic models to run everything together as a single unit. So we have here downstairs, you will see, we have a big robot, a 4-ton robot. That is the one that you see in the picture above, with a medium-sized robot that is about 70 kilo payload capacity that we are running. We are now just doing the kinematic model to run it together using ROS. Okay. At the same time, So the advantage that we are seeking is to find applications that can be used together, robots and AMRs, to work together to make real robot applications. In this case, we will make a simulation of a robot measuring a big part, and the robot is moving around the part, making measurements. Okay, we have smaller examples like the one that you see down. We have UR robots with Robotnik AMRs, and in this case we also made the kinematic. What is the results that we aim to have with the system? Very flexible system that we can do some activities with robotics that are not possible to do with today robotics. Basically, what we want to do is that the flexibility to move the robots around and to move the parts around give us a very flexible layout. So in a future, or we can imagine layouts that are not fixed, anything is fixed on a specific place. We can have the robots moving around and the parts moving around in any way we can imagine, okay? So we can make really very complex logistics in factories that are not possible today. And the last one, that's a very small project, but it's very interesting because it combines artificial intelligence and 3D measuring of that. This is the idea that the collaborative robot should be able to sense and advance its behavior according to the persons that are around. So here we add to the robot 3D. The best is to run directly the next slide. That is I don't know if it runs. Can you run the video, please? So what we have here is that really we have sensors or 3D sensors that we have a point of clouds of the persons around. We can measure what the person is doing, and in real time we are measuring the minimum distance between the person and the robot. And then at this moment we stop the robot or we decrease the speed of the robot depending on the distance directly. So we don't need really to make any special programming on the robot or anything particular, but it's a real-time system that is measuring the distance in real time and really stopping and starting transparently the robot in any case. You will see that this is the old system that is based on voxels. So what we see is a volume inside the robot area, and this volume is compared against the robot position automatically. And then we say that the robot position is acquired by the system directly, and then we stop if we detect that the distance is small. The system that you will see downstairs later, if you want, in the lab, is based on recognizing that that the person is there, that we recognize the head, the shoulders, etc. We recognize the figure, the human figure, and in this case we make the comparison and we test if the person is close to the robot. So in this case we ignore anything that doesn't resemble a person. So be careful if you enter there with some cloud on top and you don't recognize your head or something, it will not stop the robot if you enter the area, okay? And this is for examples. That means here I cannot give you any recommendation what to do with a spin-off. The only thing I can say is we are here to help you. This is our 4 examples of our activities, and we are here to help other companies to reach their own goals. Okay? Thank you very much.
Thank you very much, Francesc. So now let me introduce you Jesus Pablo González Villodres. He is Technology Transfer Manager at the Robotics and Automation Unit at Eurecat, and he will talk about cognitive robotics for Industry 5.0. So as you can see, as a network in Industry 4.0, we are already out of date. So Jesus, he will explain why. Okay, thank you.
Thank you, Maria. Hello, everyone. Hello, friends, partners. Hello. Now, yes, thank you. So friends, partners, colleagues, I'm very pleased to have that kind of meetings already. So after so many online meetings. So I'll tell you why my talk is on Industry 5.0. And it's because it's about people, not so much about robots. Most of you may know already Eurecat. So Eurecat is the largest technology center in Catalonia. We are 700 people already. We are scattered and we have facilities all across the territory. That's because we want to be close to the industry. All the laboratories respond to some nature of the industry in that region. And we are the second largest in Spain of that kind. We work all the way with companies. All the innovation run from the early stages when the idea is born until the technology is introduced to the market. And we work with end users, but we especially like to work with technology providers like most of you are here today. Before I present you our technologies, a couple of technologies that I want to present to you today that are closer to the market, I would like to start with a story about people. So decades ago, companies started to produce in mass. So the increase of consumption in the golden 20s, when thanks to the improvement of the well-being, so companies started and were forced to produce like mass production. In order to produce the highest quality products with the lowest cost, managing the lowest inventory and as fast as possible, they had to standardize products hand in hand with redefinition and reorganization systems like lean manufacturing. And the way to optimize production was to standardize factories and the workplace and the processes. So that was working well for a while, but then the demand transformed. And we got clients asking for personalized productions, customized solutions. So the size of the lot in products reduced. We had to manage more components, a major inventory. And what used to be an advantage, the standardization, was no longer an advantage, but a barrier. So standardized production lines are not necessarily agile on adapting to this change in demand. And that is why we need like flexible components, flexible technology, flexible robotics. And that is why Industry 4.0 came into place to help us. But then, like a year ago, even more, at European level, we started to talk about Industry 5.0, which the good news is that there's nothing new on technology, but it's a completely different paradigm. So 5.0 stands and leverage on three main pillars, which is human-centric. So we don't think about just pushing technology to the market, but we need to think on the use that we make as a human of that technology. So it's human-centric, so the focus is on the use, on the person, on the human, on the worker. The second is that it's sustainable, so it's climate neutral. Anything we do has to not contribute to climate change. And the third thing is that it has to be resilient. So we are aware where we come from now in the 2 last years. So anything we do, any technology contributing to our factories, our industry, needs to be resilient and can and should stand with external and extraordinary events. And that's the way we understand robotics at Eurecat. So robotics came to actually extend and expand and complement human skills. Robotics can make us see better, to be stronger, and to work faster, which means that we can produce steel with the highest quality at the lowest price and remain competitive in an international context. But again, and on top of that, we have less risky workplaces, we have more ergonomic workplaces, and we are sustainable with the planet. Okay? And that's the mindset that underpins all what we do in the 4 research lines of our group, which are focused on manipulation and collaboration, perception, which is a transversal capability for industrial and field robotics applications, and 2 research lines on autonomous robots for ground and aerial. And now it comes the 2 technologies that I want to explain to you today that we are pushing and working with companies to transfer them to the market. The first one is on mobile robotics. We've been working already 15 years in mobile robotics, and we are currently working hand in hand with companies to improve their products. So the first example is Kivnon. It is a local AGV manufacturer that wanted to move from guided vehicles to autonomous robots. They started to look at the COTS technology on the market, and they didn't find what the technology that could satisfy their requirements and the requirements of their clients. So they came to us and we customized a localization and mapping solutions for their AGVs. The second example is Aritex. Let me see, okay, now. So Aritex is a medium local company providing engineering solutions for Airbus and an aeronautical sector in general. So they wanted to develop a heavy load AGV, or autonomous robot in that case. And we worked with them into the development of that robot, and we implemented special maneuvers like the tandem configuration. So we developed a synchronized AGV working in master-slave configuration that could guarantee a separation below 1 centimeter all along the way in the working scenario. And that was thought to be used to transport wings of planes and also the wide body of the plane. At the bottom, you have two more advanced projects. The left one, let me see if the video starts again. Okay. So you have a project, a pioneering project that we are working with SEAT. And I see that the video is not running. Let me try one more time. But probably you've seen it before. Okay. So that's a pioneering project where we are implementing a drone technology to directly carry products from the provider to the manufacturing line, so directly to the OEM. So you save time, transportation time, and stock managed. Of course, it has its limitation, and that's the roadmap we are following with SEAT. And the second one is with a company, Robotics, which is actually installed here, I think, in which we are developing, and actually more and more our clients for mobile robotics are asking us that those robots should and can work outdoors. So that is where we maximize our capabilities by combining technologies. So we combine satellite navigation technologies, Galileo and EGNOS, with traditional localization and mapping technologies for robotics that stands on and rely on embedded sensors, cameras, ranging sensors, inertial sensors. These allow you to make a safe and resilient navigation and allow use and enable applications like warehouse to warehouse, transportation, and also last mile applications, last mile delivery applications. And the second example of technologies that we are actually pushing and working with companies to put it into the market, it's based on this fundamental research. So we are implementing AI technologies to provide cognitive capabilities on the robot. And that basically, the baseline on that is that the robot are able to perceive in 3D to assign a semantic meaning to what they see, so recognizing the objects and embed a characteristics and provide reasoning and cognitive capabilities on top of that. Two examples of the application of this technology. One is in manufacturing. So this is an European project we are leading, in which we are implementing this technology in 4 use cases. So there is a perception system which is able to recognize objects and recognize the position of the human. Thanks to deep learning algorithms, we are able to recognize the task the human is doing. And at the end, we are empowering the worker so that the application is no longer robot-driven, but human-driven. So the robot adapts its planning according to what the human is doing. And on the contrary, what you think that this is slower, it may be slower of a robot making a robot-driven application, but actually it helps the technology uptake. And the user and the worker feels more comfortable on the use of this technology. You could see here the 4 examples that we are implementing in that project. So we are implementing this in a capital good and metal industry and automotive railway for different applications in which the robot is actually adapting its planning to the action of the human. And as you see and as you can imagine, this is this is a technology which is aiming to deal with uncertainty. And there is no major uncertainty scenario that facing a human. And that's especially important in social applications. So that is the same technology that we are actually pursuing in several projects where we are implementing social assistive robotics. We have an strategic line funded project, nationally funded project called NOAA, in which we are working with PAL Robotics to implement this social behavior on top of a social robot. We are working on a European project, Accelerate, to introduce this in hospitals with Sant Joan de Déu. And it is the same technology that we are actually doing now with Onda Research Institute to implement adaptive behavioral change in the Aru robot. And just to finish, transferring technology could not be possible without technology providers. And in order to accelerate the innovation cycle of technology providers, we really believe on the power of networks. And we, Eurecat, we are not aiming just at transferring technology with you, but we want to connect and help you to scale up your projects. And that's why we try to be connected with our local ecosystem. This is why we are leading the robotics and advanced manufacturing node in the regional European Digital Innovation Hub. This is why we are one of the five technology centers in the only funded network of such a kind at national level, Red Cervera 5R. And this is why we are the Spanish node in the DH Square, in order to scale up technology from the local scenarios, national and international scenarios. And to do that and accelerate your innovation cycle, so we are focusing on the Red Cervera project. We want to put at your service all our facilities into 5 manufacturing pilot lines that leverages on our facilities and our assets, so that you don't have to invest on those, but make use of them to produce your products. Thank you very much, and I will be here for any question.
Is it working? Okay, thank you very much, Jesus. Really amazing presentation about what they do at Eurecat. It's a great amount of things that you do at Eurecat. So thank you for your presentation. And now to move on from IDI UPC, the Artificial Intelligence UPC Hub, we have here Javier Vázquez Salceda, who will talk about no-code robots, universalizing robots in SMEs. Okay, thank you. Yes. Here's your microphone. You have to switch it on here. Wait, okay. Yes.
Okay. So thank you for attending this very nice day. I mean, I'm Javier Vázquez, and I have many different roles, some of them very boring with administration and things at UPC. But today I can explain some fun things, some research. It's a very small research project, so it was a joint joint work with Professor Cecilio Angulo. He really wanted to be today with us. He's really sorry to attend, so actually asked me to jump in to do this presentation. And also, it was a project that we with a student that is Enrique Lamarca. First, let me introduce a little bit of the IDI Research Center, because it's a center that was created in 2017. It's integrating almost all the AI researchers at UPC, and actually now it's the biggest research center in UPC, and it's one of the biggest AI research centers in Europe. Basically, we have more than 70 permanent researchers and more than 150 PhD students. So we are a large center. This is not physically located in a single place. Actually, we are distributed with the different 5 campuses of UPC. Next one. So, I mean, robotics and the use of computers in industry has evolved a lot from the early 70s. So there was the ideas of the digital manufacturing back in those years. Then we got the computer integrated manufacturing, and now we are moving into full systems where all the parts of the company, even the design and the strategy, are connected with very complex computational processes that they also connect to the factory to be able to basically to have this flexibility and these changes in the strategy and the production to adapt to new users and new sectors. So this is something that is well known, I think, for all of you here. Let's go to, and also there is now like a paradigm shift. So for let's say 2 or 3 decades, we have been focusing into building these robotic systems that will be able to do reliable and fast movements and productions into the industrial sector, trying to be flexible with robots that were actually stayed on a single place that could not move. Now we are moving into movable robots. We are moving into more flexible production systems. And then now we just saw mobile robots that will fly on top of the factories to move things. But actually, I would like to concentrate in this talk not only on this shift into the Industry 4.0, but actually this shift on the 5.0, including the human in the loop. So actually, what I will explain in the next slides is more connected on the interrelationship between the robots and the human, and a paradigmal shift between seeing the robots as a tool that we give them tasks to develop for us, and robots becoming co-workers, co-partners. So actually trying to go into a direction where robots are not substituting humans, but actually we will build teams where humans have some role because we have some capacities that we are not able to substitute with robots. Robots have their own capacities, some things that they are maybe best than us, precision, speed, whatever. And actually we need to change some of the ways to create the new production lines to be able to encompass these hybrid teams that have humans and robots that they are co-working. So basically, one question is why cobots are not pervasive nowadays, especially in small and medium enterprises. Actually, this morning we made sort of like these questions to the fellow panelists. Maybe add 2 or 3 more reasons. So. One is that to effectively use cobots, cooperative robots, you need to change the way you organize your production system. So you need workers, operators that are able to work along with the robots to establish some sort of dialogue with the robots, maybe with signals, maybe with some fast, easy to use interfaces. So. This is like a shift. This is something that many operators are not used to, and they need training. And this might be more or less made with some good training. But then, when you want to add flexibility and you want to change tasks for some of the robots because you have new products and actually you want to change some of the tasks, or we have all these new robots that you change the tool to do something else. You need these co-workers actually to help the robot to learn new movements or to learn new sequences. So this is again something that is not what the typical operator would do. They would do it with humans, when you have like a new human enter into the team, and then more or less it's normal, and that they will teach the newcomer into the tasks. But this is something that they don't see doing with some artificial robot or whatever. And then there is a third one that is like when there is a relevant change into the process that might require changing some of the code of the robot. It's very difficult that you will have operators on the plant able to stop and actually get into the code of the robot and change it. Typically, you have to go back to a programmer in the company or to a programmer team to actually rework the code to be able to go back and continue. Okay, so what we are showing here is just a small work in this direction, trying to reduce the time that you need to go back to the programmer. To change some of the working of the cobot in a production line. So there might be many different strategies that you might reduce the need of recoding the robot. In the end, I mean, the title is a little bit exaggerated. It's Cecilius. But I wouldn't say without coding, but reducing the amount of coding needed. So typically, many strategies are used in robotics by means of demonstrations. So typically, I'm not following this anymore. By typically picking a robotic arm, and then you demonstrate to the robot some of the movements, and then the robot is able to save those movements, and they become macro operators, and then they are used in runtime. This is one strategy, and actually we had one of the projects before that used that. But actually, we are using other strategies, like actually building semantical models of the production and of the movements and of the operation of the robot. So by means of ontologies, we are able to describe the full workflow more than just an automata. It's actually describing each of the steps of the process and what they mean and what are the interrelations. So actually, the idea is that when you have described those, then we have some visual tools. So the operator might change parts of the process by recombining those building blocks, those macro operators, and then eventually, this we don't have it here, but eventually we want to connect it to some voice interface. So actually, the voice recognition will be able to interact with the model thanks to the semantics that are attached to the extended semantic workflow. Okay. So this is a very small prototype that we have built. It's built on top of the UR3 robot from Universal Robots. So basically, Universal Robots UR3, it has the arm. The arm might have some tooling on the tip. And then the main interface that Universal Robots provides is this screen, where basically you can load the program and run and execute and stop it. It is actually part of the effort that Universal Robots is doing to ease the operation and the running of the robots on the production line. But actually, we wanted to go one step beyond and actually provide to this interface this drag and drop functionality, so the operator could parameterize and modify even some of the blocks of the workflow. So basically, we have programmed a URCAP, a programmation node that is installed into the Universal Robots interface, and then you can load this extended workflow, and you can add, you can modify, you can change, you can parameterize important high-level parameters of your workflow, and then you can run it. And then we had some limitations because on one side, we first had a prototype that was very flashy, but then you have ISO restrictions on what you can apply on an interface in an industrial setup. So we had to simplify a lot. And also because the limitation of memory and processing power of that mini computer that it has the UR3. Another thing that we did was to enhance the communication between the operator and the cobot by means of a Android application. So basically, we want the robot to be able to ask for help. For instance, if there is one step in the workflow where it needs the collaboration with the human, so and then the human might not be just by the robot. So basically, with that app, the human receives a notification from the robot saying, "Hey, now I need you to come because it's this step. I need your collaboration." The human also can monitor from the distance the status of the workflow. It can actually stop and resume and pause the process from the distance with similar functionalities as the tablet of the robot, and then also the robot can send like errors, like I had to stop due to a security reason, or I had a major failure. This is a extract of the ontology. The ontology has a lot many more boxes, but actually it more or less gives us an idea of how it works from its side, because we have described the system through the ontology. So we have this workflow that is composed by blocks, and then those blocks are macro operators. Of course, we need a human to create that piece of code, to create the macro operator. And then as a parameterizable piece of code, but then the workflow is created by composition of those blocks, and then this program node is sent to Polyscope, and then Polyscope sends the commands to the robot. Then we also have the ability of the robot to connect to the app, to for instance send notifications to the human. These are just some captures of the interface of the Android application. This is how you connect. Right now in this prototype, you connect directly through the IP address of the robot. So actually, you can connect to more than one robot into your plant. This is a show that actually you can go to low-level parameters and check every single join in this case, how it is. But actually, this is we don't think that this will be the main usage of the app. This is like a high-level vision of the state of the robot. These are already relevant parameters of the high-level process. So, for instance, here. This robot is moving bases and bearings, and it's assembling some pieces. So here we have counters for the bases, the bearings, and so on. So you can monitor the status of this high-level process. And then macro operators are like pick the base, pick the joint, assemble, and then those are the macro operators that the operator can create or modify the process. Okay. And then this is just this message interface between the robot and the human. Right now, it's more from the robot to the human, but next we will start putting some natural language processing, and then the human might send some natural language commands to the robot through this interface. Eventually, this will be changed by a voice command recognition, so the human and the robot can communicate in natural language. And well, basically that's it. So this is just a very small piece of work in this vision of trying to create systems of hybrid teams with humans and robots, and there is a lot of work to do. But in any case, thank you very much.
Thank you very much. Thank you very much. Now we have Raúl Suárez, Research Supervisor at Industrial and Control Engineering Institute of UPC, and he will talk about his group research, Dexterous Collaborative Robot Co-workers. Okay, thank you very much. Thank you. You have to switch it on. Okay, thank you.
Thank you. It's working? Yes. Thank you very much for the introduction, and thanks the organizer for the invitation to present our work in this nice event. So I'm going to present some research done in our group, which is Service and Industrial Robotics. We are part of the Institute of Industrial and Control Engineering at the Universitat Politècnica de Catalunya. And next. I'm going to present some basic items we are working on related with robot co-workers. And actually we have a specific project dealing with core capability for robot co-workers. So those items I will show are part of this project currently. So first topic is related with dexterous manipulation. We want robot co-workers to have the capability of doing dexterous manipulation, and the idea is that the robot have to be able to manipulate in hand. This is moving the object with the fingers without knowing a perfect model of the object, and using only the tactile. And so there are two videos that are not running. Well, I don't know why. No. Supposed to be running all at the same time, but well, no problem. At least one is running. You may have an idea of what the others are. The only thing is that there are different cases, and so they are slightly different, no problem. So the idea is that we have to keep the force between some thresholds, maximum and minimum, avoid the object to fall, of course, and be able to control the orientation of the object. So only moving the fingers. So another topics of research are related with manipulation planning. And here we have different aspects that I will go along then in the next slide. So about grasping, planning, and defining the movement of the robot, only including not only the arm but also the base. So so the videos are not running at all now. No te escucho.
Can you?
Perfecto. Bueno.
A ver, ¿pasan?
Me decían que se estaba moviendo.
¿Pasando? ¿Funciona o no? No.
No.
Both. Well, explaining.
Well, we have a problem with the videos. They are not running on the screen.
We are sorry, so. Raúl. If not, if you explain how it moved, we're so sorry.
I'm very sorry.
Yeah. Now it's working.
Now it's working. Sorry, this is the nice part, not my talk. So let me go faster now to recover the time. So regarding the manual grasp, so we have to be able to manage larger or bigger objects with two hands. And here we have a couple of examples about how to grasp the object depending on the orientation of the object with respect to the robot, of course. I will not enter into technical details, but you can see that the videos are self-explanatory. So another point is the coordination of the arms. So we have here an example where each hand has to arrive to the one green cylinder, and they have to remove the object. So we can plan the movements of the arm for each arm separately, which simplifies a lot. But then we have to coordinate the movements, and you have just seen on the screen how one arm have to move back online to let the other arm go to the goal. So, and this is the hard part of the parallel execution of both movements. So having achieved the coordination of the arms. So, well, this is a part where the left hand has to move back, and now he can follow the predefined path. So, but not only grasping, you can remove objects just by pushing them. So here we have a simulation and a real example of how to plan movements of the arm, just pushing the obstacles away from the path. Of course, having in mind several constraints, so you cannot push the obstacles out of the workspace, in this case the table, so they will fall down, of course. The idea is to arrive to the goal without pushing the goal, and without letting the obstacle fall down out of the table. This is a more complex example. Here we put everything together. So the robot have to grasp an object with the right hand and move it to the left hand by putting the object in some middle space in the table. So in one of the cases, in the upper left, well, it was already run down, the object decides to push the object, the obstacle, the yellow can, in order to make some room for the deposit of the manipulated object that will be later grasped by the left hand of the robot in order to, again, pass it to another robot. So while in the bottom right example, at some point we will see, so the object decides to grasp the object, put it in another place, and then have some room to manipulate or move the object, the manipulated object from one hand to the other. So these are two examples that were obtained automatically. So we use here ontologies, and of course we have to have a knowledge of the environment and the current situation of the environment. We have to make motion planning to determine the motion of the arms to grasp and move each obstacle, each object, and of course the task planning, because in order to do the task we have to decide what to do first and what to do later. And everything here is put together. So, but collaborative robots have a requirement, is they have to have human-like movements. So we started with the arms. We captured the movements of a person doing some particular task. We experiment with different tasks. We will have no time to discuss that. We mapped this movement to the robot, to the manual robot, and then studied these movements in order to obtain basic movements. This is the first basic movement. This is the second one. And then by just choosing a small number of these basic movements, we can reproduce with low complexity the human-like appearance of the movements. So here the task was planned and executed using human-like movements, which for a robot collaborating with a human being is much better, of course. But when we talk about human-like movement, we have another issue here. What is a human-like movement? So I always put the example that I have a college doing the same task I do in the same place, and we do not do the same movement. So who is more human? He, the other person, or are myself? We both are human, but we need to measure it in some way. And we have proposed a measurement, and here we have two examples. This is an artificial, this is an artificial movement generated to assembly the two objects, and we have a human-like index of 0.04, which means that it's not, this is a rank between 0 and 1. This means it's not very nice human-like movement. While this one has 1 order of magnitude more of human-like index, is 0.5. So we can evaluate how human-like is a movement when we are planning and executing robot movements with an anthropomorphic shape. And just to show a last topic, we include the base of the mobile robot in this approach. So again, we capture movement from the human being doing, going to grasp the green cylinders on the table, and starting from different positions and orientation of the human being, and analyze the movement, and they make the robot follow that kind of movement. And you can see in the top left, the planner was not oriented to human-like movement, and the movements of the arms are not quite related with the movements of the base. While in the bottom right example, you can see that the approach of the robot to the table and the movements of the arms are more coordinated. So we do not want a sleepwalker that extend the arms and walk to the goal. We do not want neither that the robot move to the goal, stop there, and then start using the arms. We want a coordinated movement. So we want to move the arms in a natural way when we are approaching the table. This is similar in some way to the examples I showed before regarding only the arms. And we have also included in this approach the hand. But I think this is enough to show more or less which are our research lines regarding collaborative robotics. These are pictures of our lab. The top picture shows the lab more oriented to industrial robotics, but the second one is the collaborative robotics. So you can see there that the robots are free, no fence, are not closed. And below you have some picture of mechanical hands that we use a lot, and some other of the robots. And thank you for the attention. That's all from my side.
Okay. Thank you very much, Raúl. So thank you for your presentation. And last but not least, please welcome to the stage Sergi Foix from IRI, Institut de Robòtica i Informàtica Industrial, a joint research center of the Spanish Council for Scientific Research, CSIC, and EUPC. Okay, thank you.
Thank you, Maria, and thank you, everybody, for being here. So, well, as Maria said, I'm part of the group of the Perception and Manipulation Group at IRI. So I will first make a little bit of introduction of our institution. So in our institution, we are 4 main groups. One based in one research team that it's based on kinematics and robot design. One based on mobile robotics. Another one based on automatic control, and the group where I belong to, that's the perception and manipulation group. So these are more or less the robots that we have used and we have at the institute. The kinematics and design robot group basically does parallel robotics and design of different strange and complex kinematic chains. And we have the mobile robotics group that bases in social robotics in outdoors, basically. It also has a group dedicated into aerial robotics with drones, and the automatic group at the institute is mainly based in the control of fuel cells and also in hydraulic management of water. And in our group, that it's the manipulation and the perception and manipulation group, we are based on assistive robotics and manipulation of deformable objects. In our group, we are actually the biggest group at the institute. Right now, we are around 50 or 60 persons between permanent positions, postdocs, and mainly students. So, and as I was saying, our group is dedicated to assistive robotics and also to rehabilitation. So we have a research area basically dedicated to being able to give food to persons, also to dress somebody with some kind of disabilities, and also we are also dedicated with to putting some kind of robotics in helping to healthcare systems in order to help to keep the mind active while you have some kind of cognitive problems. In this case, it's dementia or Alzheimer. We also have a group dedicated specifically to computer vision, mainly doing deep learning for feature extraction or metrologic measurements in wider fields like football, or in detection of complex scenes like in recycling processes. Also in fashion. So in order to be able to segment different type of complex scenes in fashion, they are having a lot of success with retailers of fashion, so they can change the type of clothes that they are wearing in online. But basically what I wanted to explain to you in this presentation is the path that we have followed in our group in order to create a spin-off. And that path is based on different types of projects that we have been doing in research. I will put all these videos, but mainly we are dedicated on putting some artificial intelligence in processes like industrial planning in a symbolic way. So in the video on the top left, we have shown the robot how to make some kind of actions and then reasoning about it in a symbolic level in order to be able to accomplish the task and ask for help to an operator in those terms where they cannot fulfill the task. But also it can explore the planning level and then provide some new solutions. In another, let me take back and again. Apply. In another research, we teach robots using reinforcement learning, showing the robots how to fulfill a task in a very coarse way, like in that part that it's manipulating a T-shirt, and then leaving the robot to explore its space in a minimal condition, so it doesn't explore the whole thing, just in order to improve. And then by reinforcement learning, we manage to fulfill the task in a better way. In this case, the cost function was to make the T-shirt in a square, with somehow it did it correctly, and then we also have 3D pose estimations of human in a very complex scenes, like you can see. So only based on single images. And from all those, from all this knowledge, we became kind of experts in decision making, using machine learning algorithms, process modeling, and predicting actions in a symbolic and also in a low-level plan, and also in doing some planning. We also became quite experts in anomaly detection, so using those computer vision, based deep learning technologies in order to detect some specific features. And then we try to combine all these technologies in technology transfer projects. And that's more or less the path that we have followed. We started at the 2012, doing some technological transfers. And we were doing some decision-making technological transfers based on what we wanted to call comfort versus consumption decision. So the user doesn't have to try to do kind of programming. It can only decide, if in your system you want to be, convenient for the human in some way. In the way of the elevators was that you want to have the elevator as soon as possible in your floor. Or in the case of air conditioning, you want to have your area in the condition that you wanted, in 24 degrees at 8 o'clock in the morning. So I want the full comfort. Or you can have, kind of controversy, you want to be care of the consumption. So one thing and the other cannot be possible, or you want to be half and a half. And then our system was able to take the decisions in order to make, okay, maybe you will not have at 8 o'clock the perfect temperature at your room, but you will have enough temperature based on the consumption that you wanted to know. Your goal was be low in consumption instead of comfort. So basically with those parameters, we try to apply it in any kind of situation or any kind of project. In another type of projects that we were also developing were in anomaly detection. So we had a lot of experience detecting this type of characteristics in RGBD images, and also we apply it in thermic images. And we succeeded very well. And also we put some, based on the whole system, similar to all combines, it's the IPIX projects that's in the Metal Factory project, that we tried to do some kind of anomaly detection, but not in a very short term, but in a very long term. So depending on the variables that on the production, we could model the process, be able to do some predictions, and then took some actions in order to improve the capabilities of the production. And all that kind of knowledge, we were able to put it together in a software package, and that software package we were able to license it, and we were able to create a spin-off thanks to that package. And we did that 4 years ago. We are very happy that although the pandemic, we are still on the system, and basically now we are doing predictive maintenance. That's one of the focus, but we are still, working in a very specific, and that's maybe one of the lessons learned that we have learned in the spin-off, is that you have to adapt to whatever the community demands. Your clients need something, and we were in a very in a lucky place in the sense that we already knew that there was a demand of our product because we were doing those transfer technology products, and the companies were asking for maintenance, for keeping in touch, and we, as a research institution, we couldn't. So we decided to create this spin-off in order to give, to be able to give that solution to the clients. But at the same time, you have to be versatile and change whatever, Listen very carefully what are the needs of your client and adapt correctly. And that's our main contribution. And that's all. Thank you.
Perfect. Thank you very much, Sergi. Thank you for your presentation. And now it's Q&A, time for questions. Is there any question from the public? No questions. Everyone is tired. It's lunchtime, so okay, the microphone.
This is a question for regarding the social robots. So I had read, I don't know, a long time ago, about how robots, if they are, let's say, if they're if they're designed to be too much like a machine, then people don't kind of connect with them. But at the same time, if you design them and they're too human-like, they're also, like, people are almost afraid of them. So you have to kind of like find this balance. So my question for the social robots and the designers, like, do you take into account this kind of like psychological aspect when you're designing social robots or any kind of robots that are going to be in like the rehabilitation or hospital environments, or if they're going to be acting like a coworker, so they'll be part of a team? Yeah.
Who wants to answer the question? I mean, Francesco.
Yes, what you described is called uncanny valley. That is something that was studied in Japan, and this is exactly the theory about the design of this kind of robots, because we can't imagine to have a social discussion with a washing machine. So, so aesthetics is very important in the interaction, but not only the aesthetics, but also other things. From certification point of view, for example, the pitching point. So you have to design the robot in order to don't have the user even with some problem using the robot as to be always safe. So this is something that has to be taken into account. But absolutely, aesthetics is one of the important things, and even most important because it's completely different design a robot for a European, for a American or Asiatic people, because we are different from worldwide. We are completely different, and so having a robot that could be good for all the different social part is complicated. But yes.
Okay, thank you very much. Other questions? If he wants to answer also.
I wanted to add a follow-up to the question, because actually in the case of, let's say, physical embodied robots of the size similar to the human, then it becomes critical. Especially if the human is not, I mean, let's say if it's an elder person, is general population. Because if you are in the industry, your robot can look totally, well, all the lines we have seen about all these platforms that move, and they will not care. For instance, and actually this may also apply to software. I mean, what I explained here is just applying the concept of collaborative AI to robotics, but collaborative AI applies to algorithms and methods. So basically, it can also apply to your classification method that stops being just a tool that you use and then you continue, to something that the human is able to perceive, interpret, and classify some part of the data. The AI is able to classify, pre-process part of the data, and actually the final decision is a joint work between the AI and the human. And an specialist, you can train him or her to be able to work with that AI or that robot without having a fancy face or. So actually, my answer would be depends.
Okay, thank you. Some more questions?
Yes, just a very short comment. This is also related about why we look for human-like movement of the robot. From the energy point of view, it's not necessary to be human-like. From velocity, maybe it's not also necessary to use human-like movements, but from the acceptance point of view, human-like movements makes the people feel much more comfortable. So.
Okay, thank you. Very interesting. Some more questions? Okay, no more questions. No, so to wrap up, thank you everyone for coming. It has been really interesting, really, it has been a pleasure. I hope you have enjoyed the presentations, you have learned, and that this has been an opportunity for you to have a quick overview of the sector, an opportunity also for you to collaborate, to network, and thank you Leitat for the organization, and also Eurecat and all the institutions that have contributed to the organization of the event. And on behalf of the Shafir Network, we hope to see you again in future events. Please check our website and our social networks. And thank you very much. The event will also be posted on our website, so you can check it later. And now I want to remind you that there's an optional guided visit to the factory at 2. So if you want to go there, don't move. Please stay here. So thank you very much, everyone. Okay. Thank you.